Hello, and welcome to Sleep Gravity. There are nights when, if you are sitting on a train, passing through a land far to the north, all that remains beyond the window is darkness, a few small lights, and quiet stretches of snow drifting by. Everything seems to have slowed down, the steady sound of the wheels, the slightly cold glass, and above the horizon, the night sky opening wide, like a space without an ending. Then, somewhere in that darkness, a streak of green light appears. It does not flash like lightning, and it does not stay still like a star. It moves very slowly, soft and wide, as if the sky has a current of its own. We call it the aurora. But behind that quiet beauty is a scientific story that begins very far away. The sun does not send Earth only light and warmth. It also continuously releases streams of electrically charged particles, what scientists call the solar wind. Most of the time, we cannot see that stream of particles. But when it meets Earth's magnetic field and the upper atmosphere, something invisible can become light. Tonight, we will follow that journey slowly, not to turn the aurora into a dry lesson, but to understand why oxygen can create green light, why nitrogen can add shades of purple and blue, and why the polar regions are where the sky often begins to glow first. Beyond the imagined window of that night train, the ribbon of light is still drifting, and the question that stays with us is a gentle one. How did the sun touch Earth's sky? Outside the window of the night train, the northern sky is no longer just a stretch of darkness above the snow. For the first few minutes, everything still seems ordinary. The tracks running through a land with few lights, low rooftops slipping slowly into the distance, thin black rows of trees standing still in the snowy fields, while inside the train car, the steady sound of the wheels makes time feel slower. But then, in one far corner of the sky, a faint glow begins to appear, so thin that a person might think they are seeing it wrong. It is not dazzling, it does not flash, and it does not announce itself with any dramatic instant. It simply rests there, slightly tilted against the black sky, like a very soft line of color that someone has drawn through the darkness. At first glance, someone might think it is cloud, but clouds do not have that strange green color, and clouds do not change in that way. That streak of light does not drift heavily with the wind. It is softer, slower, as if a quiet movement is running through the sky itself. After a while, it stretches out, then curves, then fades at one end, and grows brighter at the other. It is not like light from a distant town, because no town on the ground could illuminate such a wide piece of high sky. It is not like moonlight either, because moonlight always has a source, a direction, and familiar shadows. This light seems to be born inside the darkness itself, very high above the ground, in a place the human eye can never reach. It is the aurora, one of those phenomena that can make people fall silent before they even understand it. Not because it is loud or overwhelmingly bright, but because it appears in a way that is difficult to hold on to. Sometimes it is only a faint green streak along the horizon. Sometimes it opens into a long band of light, like a thin curtain. Sometimes it almost disappears, making the viewer think everything has ended, only to return a few minutes later in another part of the sky, wider and clearer, as if the night has quietly changed its mind. On that train, if a passenger presses a hand against the cold window and watches a little longer, the thing that awakens curiosity is not only the beauty of the glowing band, but a very simple question that is hard to let go of. Why does the sky light up there? Not at sunrise, not in the last glow of sunset, not around the sun or the moon, but in the middle of a cold night, in regions near the poles, where the ground is almost silent, and every human light is too small beneath the vast sky above. Long before humans had satellites, magnetometers, or instruments for observing space, the aurora was seen through imagination. For people living beneath the northern sky, those ribbons of light could not have been ordinary. They were too strange to be dismissed as clouds, too alive to be mistaken for stars, and too distant for people in the past to easily verify. So many cultures once connected the aurora with spirits, omens, heavenly fire, or stories belonging to a world that human beings could not see in everyday life. That is easy to understand. When a dark sky suddenly opens into moving layers of light, the human mind almost naturally wants to find a larger meaning within it. But what is interesting is that science does not make this phenomenon less mysterious. Science only makes the question deeper. As observers began recording the aurora more carefully, they realized it did not appear entirely at random. It often came to regions near the poles. It could become stronger at certain times. It was connected to changes the human eye could not see. On some nights, the sky showed only a very weak, thin streak. On other nights, the light spread so widely that the entire horizon seemed to have a river of color flowing across it. That beauty was not only beauty, it was a sign. And that sign seemed to be saying that something between Earth and space was happening, even while the ground below remained completely still. What makes the aurora so fascinating is that it does not begin where we see it. The ribbon of light in that cold sky is only the final visible part of a much longer journey. It is the result appearing before our eyes, while the true cause lies farther away, in the place where our daylight is born. In this story, the sun is not only the bright circle that rises in the morning and sets at the end of the day. It does not only send sunlight to warm the ground and make the oceans shimmer. It is also constantly active in ways ordinary human eyes cannot recognize, always sending its influence into space, always causing Earth to respond, even when we are in the middle of a very quiet night. And that is where the story begins to pull us in. How can a star so far away, already hidden from the night sky, still leave a trace above us? How can a planet resting in darkness glow because of something that began at the sun? Why does that light often appear near the two poles instead of spreading evenly across every sky? And why, when it is all the same aurora, does it sometimes look pale green like the sky's own breath, while on other nights it carries thin shades of red, purple, and pink that a camera may see more clearly than the human eye? These questions do not need to be answered too quickly. If we answer them too fast, the aurora becomes only a scientific diagram, while what holds the eye is the feeling that many layers are hidden behind a very quiet band of light. We can begin with the most certain thing. The aurora is not reflected sunlight like moonlight, and it is not a cloud glowing by itself because of the cold. It is a real phenomenon of the atmosphere and space, one that appears only when several invisible things meet in the right way. Something comes from the Sunday. Something belongs to Earth. Something lies in the very high layers of air above our heads. And when they meet, the darkness near the poles can turn into color. Below, the train is still passing through quiet, sparsely populated land. No one hears any sound from the ribbon of light above, because the aurora does not need sound to draw attention. It only changes very slowly, slowly enough for the human eye to doubt, then believe, then keep watching. Sometimes it looks like a green curve stretched across the night. Sometimes it hangs down in thin folds of light, like a curtain made of no material at all. Sometimes it grows still, almost dissolving, leaving behind the feeling that the sky has hidden something away before we could fully understand it. In photographs, the aurora often appears brighter, sharper, and more colorful. That, too, is part of the curiosity. The human eye sees light in the moment, while a camera can gather light for a little longer, holding on to faint colors that the darkness softens. So a person standing under the real sky may see an aurora that is gentler than the photograph, dimmer and more modest, but perhaps, for that very reason, closer. Not all of the aurora's beauty lies in its brilliance. Sometimes it lies in the need to wait, to look slowly, to let the eyes adjust to the darkness before realizing that something immense is unfolding silently above. The aurora does not always appear according to human wishes. Going to a polar region does not guarantee that you will see it. A dark sky does not automatically open into green light. It needs its own conditions, its own movements, events that began before the observer ever stepped onto the snow or boarded the night train. That uncertainty is what makes it different from a lamp switched on at a scheduled hour. People can search for it, forecast it, and wait for it, But there is always a space that cannot be fully controlled. And that space allows the aurora to keep the living quality of a true natural phenomenon. Outside the window, the pale green band changes shape again. This time it is thinner, but higher, as if it is being lifted from the horizon. A little later, its middle glows softly, while both ends dissolve into the dark. The train is still moving, people are still sitting in the car, and everything on the ground still belongs to ordinary life. But above, the sky has opened a small doorway into a larger story. The story of how the sun, earth, and the atmosphere meet to create light in the night. To enter that story, we do not need to leave the quiet. We only need to follow the trace of the glowing band from the place where it appears before our eyes, back toward the place where it begins. And that beginning is not in the clouds, not in the snow, not on the northern horizon. It is in the sun, the star so familiar that we sometimes forget it is not still, not gentle, and not only sending daylight to Earth. There is a misunderstanding that can happen very easily when we look up at the night sky. When we see the moon shining, we know it is not making its own light, but reflecting sunlight back toward Earth. When we see the clouds at the end of the day tinted pink, we understand that the last sunlight is passing through the atmosphere at a low angle. When we see snow sparkling under distant lights, we know that some source of light is touching it. From childhood into adulthood, human beings become familiar with the idea that light in the sky usually has a clear source. The sun, the moon, stars, city lights, or some object reflecting the light it has received. So when the aurora appears as a green band drifting through the night, it is easy to imagine that the sky is reflecting some kind of light from outside. But the truth is different. That ribbon of light is not sunlight left behind after sunset, not moonlight scattered across clouds, and not a high layer of ice in the atmosphere catching light and returning it to the human eye. The aurora is light born within Earth's upper atmosphere. That difference may sound small, but it completely changes the way we see the phenomenon. A lake can reflect the moon because it has a surface. A pane of glass can reflect a lamp because it is smooth enough to send light back. A cloud can change color because it is being illuminated from a certain angle. But the aurora does not need a mirror in the sky. It does not appear because the sky catches light and reflects it downward. It appears because gas particles very high above our heads receive extra energy and then release light of their own. On the night train, this is not obvious at first glance. The person sitting by the window only sees a thin band of light, sometimes curving upward, sometimes fading, sometimes hanging down in a few very soft folds. Visually, it feels almost like a curtain, which is why we often describe the aurora as a curtain of light. But that is only the way the human eye describes its shape from far away. If we could move closer to the place where that light is being made, we would not touch any green fabric, and we would not pass through a curtain suspended in the air. We would enter a very thin region of the atmosphere, where countless small collisions are creating tiny pieces of light. The air there is not like the air around the railroad tracks, around the train car, or around the snow-covered houses below. The higher we go, the thinner the atmosphere becomes. The molecules that are so familiar in everyday life become more spread out, existing in a transition zone between the planet and space. Oxygen is still there. Nitrogen is still there, but they no longer feel like air to breathe. They exist in a vast and cold region, where particles coming from beyond Earth can strike them in very special ways. When an energetic particle collides with oxygen or nitrogen high in the atmosphere, it can pass some of its energy to them. For one very brief moment, those atoms and molecules enter an excited state, almost as if they have been lifted out of their ordinary condition. Then, as they return to a more stable state, the extra energy is released as light. A single collision is far too small for us to see. But if countless collisions happen across a wide region, their combined result can become a glowing band stretched across the sky. This is why the aurora appears so soft, while also having such a precise origin. The human eye sees a streak of light drifting like silk, but underneath, it is not silk, not cloud, not smoke, and not light bouncing off a surface. It is the atmosphere glowing after receiving energy. It is a phenomenon taking place at an altitude that everyday life almost never reaches, yet large enough for a person standing on the ground to look up and see it. Compared with moonlight, the aurora is alive in a different way. The moon shines because it receives light and reflects it back. Its shape changes slowly according to a familiar cycle. The aurora can change while we are watching it. A thin green line can split into several layers. A dim region can suddenly grow brighter, and a fold of light can hang downward and then dissolve as if it had never been there. That movement is not caused by an object flying across the sky, but by a process unfolding in the upper atmosphere, where energy is constantly being delivered and then returned as light. This is also why the aurora is not always as vivid as it appears in photographs. A camera can keep its shutter open longer, gathering faint light over several seconds, making green, purple, or red tones appear clearer than they do to the human eye in the dark. But when standing under the real sky, people may sometimes see only a very faint glow, something they almost have to watch slowly in order to notice. That does not make the aurora any less real. On the contrary, it brings the phenomenon closer to nature. The universe does not always reveal itself in strong colors. Sometimes it leaves only a thin sign, just enough for a patient observer to realize that something is happening above. From the difference between reflected light and self-made light, the story begins to open another door. If the aurora is the atmosphere glowing, then what energy has awakened that layer of air? The air around us does not change color every night on its own. The oxygen in our breath does not give off green light when we turn off the lamp. The nitrogen in the city, above the sea, or among the pine forests does not suddenly become a glowing curtain. There must be a source of energy entering the right place, in the right way, with enough strength to make the upper atmosphere release light. That energy source is not underground. It does not come from the moon either. It begins much farther away, at the sun, but not in the familiar way of daylight. Here, the sun is not only shining, it is sending invisible streams of particles into space, and those particles are the part of the story that human eyes cannot see while standing beneath an aurora-filled sky. Outside the window, the glowing band overhead may still be changing shape. The people in the train car see the green light, but they do not yet see the path that carried energy there. They see the light, but not the tiny particles that left the Sunday. They see the sky glowing, but not Earth's invisible protective shield, quietly deciding where that light is able to appear. The aurora, then, is not only a beautiful scene in the night, it is the visible part of a chain of events, most of which remains beyond our sight. Once we understand that it is not reflected light, we have crossed a very important threshold. The polar sky is not simply a background receiving light from somewhere else. Under special conditions, it becomes a place where light is created. And to understand why that can happen, we need to trace the story back toward the energy source that set everything in motion. The sun, not as a soft sun over snow or warm sunlight on a window, but as a star constantly blowing material into space. The sun does not only send light. Once we know that the aurora is not reflected light, the green band outside the window of the night train suddenly carries a different meaning. It no longer feels like a random glow lying across the sky, and it no longer feels like a layer of color being projected onto the darkness from somewhere else. It feels more like the final part of a journey that began before that passenger sat down beside the window, before the train left the station, even before the northern night became dark enough for that green color to appear. Not the gentle sun we remember from everyday life, where sunlight falls through curtains, warms a hand, dries a road after rain, or lays a pale golden color across rooftops in the morning. The sun of the aurora is an active star, a giant sphere of plasma with a surface that is always moving, with magnetic regions twisting, opening, and sometimes releasing energy in ways that, from the ground, human eyes cannot see directly. From our distance, the sun seems so stable, that it is easy to think of it as a large lamp in the sky. But in truth, it never simply stands there and shines. From the sun, light still travels to Earth as it does every day. Because of it, daytime has color, plants receive energy, the ocean's surface sparkles, and the shadows of objects can stretch with the afternoon. But alongside that familiar light, the sun also continuously releases into space a very thin stream of matter, made of tiny electrically charged particles, mostly electrons and protons. That stream has no shape for our eyes to recognize, no sound blowing across a window pane, and it does not stir a branch on the ground. It is called the solar wind, but that gentle name can easily make us imagine it incorrectly. The solar wind is not wind in the everyday sense. There is no air flowing from the sun to Earth like a cold breeze blowing from the sea onto the shore. Between those two worlds is interplanetary space, vast, thin, and almost nothing like the atmosphere around us. What travels through that space is a flow of charged particles, escaping from the outer regions of the sun and spreading throughout the solar system. They pass through the orbits of the planets, move through thin regions of dust, and cross a space that human beings often imagine as empty, even though it is always filled with quiet currents of motion. This makes the sight of the aurora feel deeper. In the polar sky, we see a slow, soft band of light, but before that light appears, a stream of particles has left the sun, traveled across millions of kilometers, and entered the region of space around Earth. That entire process does not appear before the eyes of someone standing in the snow. No one sees each tiny particle leaving the star. No one hears them moving through space. No one feels them touching the roof of the train or the window glass. And yet, at the end of their journey, part of their trace can become color in the sky. Perhaps this is what makes the sun in the story of the aurora different from the sun of everyday life. During the day, it feels close because its light touches our world directly. We see it through sunshine, through shadows, through the warming of the ground. But on nights with auroras, the sun is present in a more hidden way. It does not appear on the horizon. It does not illuminate the whole landscape. It has long since set, or it is on the other side of Earth, but its influence is still moving through space, reaching the invisible protective region around our planet, and leaving behind a streak of light very high above. The solar wind is always present, but it is not always the same. There are times when the sun is relatively quiet, when the stream of particles reaching Earth is gentler, and the polar sky may keep only a deep darkness. There are also times when the sun is more active, when complex magnetic regions on that star make the particle flow more energetic, or send larger bursts of material away from the corona. From the ground, those changes may not make the morning look very different. A person still sees sunlight on the sidewalk, still sees white clouds drifting by, still sees the sun as a familiar bright disk. But space-observing instruments read a completely different sun. Not calm, not simple, and never truly still. That is why the aurora is not only a story of the night, it is also the story of a hidden daytime behind it. A ribbon of light appearing at midnight may have been prepared by motions on the sun long before. A thin green streak in the cold sky may be the result of particles that left the star many hours earlier, crossed the wide emptiness of space, and met Earth under the right conditions. The quiet beauty we see at the end does not deny the force at its origin. It only shows that nature can transform a powerful process into something very gentle. Outside the window, if the aurora is still there, the passenger may see only green light fading slowly against the sky. But within that green, there is a story the naked eye cannot read all at once. There is the light of the atmosphere. There is energy from space, and farther away, there is a star constantly leaving its mark on the planets around it. The sun does not only hold Earth in orbit through gravity, and it does not only bring the new day into being with light, it also creates a vast environment surrounding the entire solar system, where the planets are always moving through invisible streams of particles. From this point of view, The space between the sun and earth is no longer a completely silent emptiness. It is more like an extremely thin ocean, where currents do not raise waves like the sea, but still carry energy far away. Earth moves through that ocean every day, surrounded by its magnetic field and atmosphere, belonging both to familiar life on the ground and to the space environment it constantly touches. The aurora is only the rare moment when that connection becomes visible. And yet, the sun is only the first part of the path. The particles that leave it do not automatically become an aurora as soon as they approach Earth. If our planet did not have an invisible structure surrounding it, if those particles were not bent, held, or guided toward particular regions, the sky would not light up in soft rings around the poles the way we see it. In other words, the sun sends the first material, but Earth decides how that material is received. This is where the magnetic field enters the story. Unlike light, which the eye can see, a magnetic field does not appear as a color in the sky. It has no surface, no sound, and no clear outline around the planet. But this invisible thing is the reason Earth is not simply swept by particles from the sun like a bare stone in space. The magnetic field makes the story of the aurora more subtle. It both protects and guides. It deflects most of the particles, while allowing part of the energy to enter the atmosphere in the right places. So when we look at a band of aurora in the sky, we are not only seeing the final trace of the solar wind, we are seeing a conditional meeting. The sun has to send particles. Earth has to have a magnetic field. The atmosphere has to be there, thin but still able to glow. And only when these layers connect can the polar night begin to change color. The train continues moving through the northern darkness, while high above, that ribbon of light may be fading away or preparing to open into a new shape. But behind its gentle motion, the story has left the small window and expanded to the scale of the entire planet. If the sun is the beginning, then Earth's magnetic field is the next doorway. To understand why the aurora does not appear everywhere, why it often gathers near the poles, and why our planet can turn an invisible flow of particles into light with shape, we need to enter the colorless protective layer surrounding Earth. The band of aurora outside the train window seems as if it is very close. It hangs just above the snowy forest, lower than the distant stars, wider than a streak of cloud, soft enough that the viewer may feel that if the train travels just a little farther, it might arrive beneath the place where that light is opening. But that is only the impression the human eye gets from the ground. In reality, that quiet ribbon of light is the final part of a much longer journey, a journey that began at the sun and crossed the space between planets before leaving its trace in the polar sky. That space is often called empty, and in one sense, it truly is emptier than anywhere human beings are used to living. There is no air to breathe, no clouds, no rain, no sound traveling the way it does through Earth's atmosphere. But empty does not mean motionless. Between the sun and Earth, tiny particles are still passing through, invisible fields are still spread out, and changes the human eye cannot see are still taking place. If the atmosphere around us is a place of wind, rain, and snow, then the space around Earth has its own kind of weather, only it happens through charged particles and magnetic fields instead of water vapor or cold air. The solar wind is part of that weather. It leaves the sun not like a breeze blowing through an open door, but like an extremely thin stream of matter escaping from the hot outer region of the star. Within that stream are protons, electrons, and accompanying changes in the magnetic field, all gradually spreading throughout the solar system. If sunlight reaches Earth very quickly, in only a few minutes, these particles travel much more slowly. They need time to cross the great distance between the star and our planet. Meanwhile, on the ground, life continues in its ordinary rhythm. A train passing through the cold night, a small town dimming its lights, a person pulling up a collar while stepping onto a station platform, completely unaware that far above, a stream of particles from the sun is approaching. Perhaps the hardest thing to imagine is how thin that flow really is. Calling it wind can make us think of something the skin might feel, But if we were standing in space, it would not resemble wind on Earth. It is far too sparse compared with the air around us, far too silent compared with anything the human senses know. And yet, its thinness does not make it meaningless. In space, even a very sparse stream of particles can create a large effect if it travels far enough, fast enough, steadily enough, and carries electric charge. A single particle does not create an aurora, but a continuous flow of particles, meeting a planet with a magnetic field and an atmosphere, can open an entire chain of interactions that is finally seen as light. We might think of very fine dust in a beam of sunlight. One speck of dust alone seems almost too small to matter. But when light passes through at the right angle, countless tiny particles appear together, and suddenly we realize that a room we thought was transparent is still filled with quiet motion. The solar wind is not like dust in the air, but the feeling of discovering something invisible is somewhat similar. Most of the time, we do not see it. Then, under certain conditions, the polar sky begins to glow, and a hidden current of motion suddenly leaves a trace behind. That stream of particles does not move through space like a simple arrow. The sun rotates, Earth moves in its orbit, and the magnetic field carried within the solar wind is drawn into curved and far more complex structures than a straight line. We do not need to turn this into a difficult lesson about plasma or magnetic field equations. It is enough to sense that the space between the sun and Earth is not an empty stage. It is a changing environment where streams of particles and invisible fields are always shifting, sometimes gently, sometimes with more force, like a sea too thin to make waves out of water, but still carrying currents of its own. The sun also does not release this flow of particles in the exact same state forever. There are periods when it is quieter, times when it becomes more active, and regions on its surface and in its corona that grow more complicated because of magnetic fields. When those disturbances are directed toward Earth, the space environment around our planet can change. For someone standing beneath the sky, this is not always immediately obvious. A morning can still look like any other morning. A cloudy day can still look only like a cloudy day. But at observatories and on satellites monitoring the sun, those changes may already have been recorded before someone in the far north sees the first green band. This is one of the quiet beauties of the aurora. When it appears, we usually see only the final moment, light in the sky. But that moment has a past. It has a long path through space, an energy source that has left the sun, a journey across emptiness before Earth has time to respond. A ribbon of light may exist for only a few minutes before the viewer's eyes, but the things that brought it there began much farther away and much earlier. Thanks to satellites, humans today no longer have to wait for the aurora as a complete surprise. Instruments can monitor the solar wind, measure the speed of the particle flow, measure the direction of the interplanetary magnetic field, and help predict when the polar sky may become brighter. Those numbers can feel dry when they stand alone, but when placed beside the image of someone sitting in a night train car and looking out at a glowing band overhead, they become deeply meaningful. They show that this beauty does not fall out of nowhere. It has warning signs, a path, and a rhythm of its own, even if that rhythm unfolds in a place far too high and far too distant from ordinary life. Even so, forecasting the aurora has never been like switching on a lamp. People may know the conditions are becoming more favorable, measure a stronger solar wind, and see changes in the space environment. But the real sky still keeps part of itself unpredictable. Clouds may hide the light. Human eyes may not be sensitive enough to catch a weak aurora. One burst of activity may create a brilliant display in one place but leave only a faint trace in another. That lack of complete certainty is what makes seeing the aurora feel like encountering something alive, rather than watching a performance that has been programmed in advance. On quieter nights, the solar wind still passes by, but the sky may show nothing unusual. On more favorable nights, even a thin layer of light is enough to make someone standing under the cold sky forget the time. And then there are rarer nights, when the sun is more active, when the particle flow reaching Earth carries more energy, and the aurora expands, grows brighter, and sometimes moves beyond its familiar polar regions. At those times, people at lower latitudes may also see a faint red glow or a strange band of light near the horizon, as if the north has sent part of its sky farther south than usual. But whether faint or strong, near the poles or farther away, the aurora always points to the same truth. Earth is not drifting through an indifferent emptiness. This planet lives within the influence of the Sunday, not only through daylight, not only through warmth, but through a thin stream of particles passing through space, constantly tapping gently against the invisible protective region around the planet. Most of those taps create no scene for human eyes. But sometimes, under conditions that are just right, a little energy reaches deeper, meets the very high layers of air, and the night begins to have color. Outside the train window, the glowing band may be changing shape very slowly. It does not tell the viewer how many millions of kilometers it has crossed. It does not reveal the speed of the solar wind, or speak of the satellites measuring far above. It simply appears as a quiet streak of light. But once we know that behind it lies an invisible flow from the sun, that stillness becomes deeper. A phenomenon that looks fragile is actually connecting a small passenger in a train car to a giant star at the center of the solar system. From here, the story does not need to hurry away from that silence. The stream of particles from the sun is still moving toward Earth, but before it can touch the atmosphere and create color, it meets a region the eye cannot see. That region is not like a wall, and it is not like a layer of glass around the planet. It is wider, softer, and always changing under the pressure of the solar wind. If we think of the aurora as a very slow piece of music played by the sky, then the solar wind is the first breath passing through the instrument, while Earth's magnetic field is the quiet shape that decides where the note will sound. The northern night still stretches outside. The snow still slips away behind the glass. The sky still holds its ribbon of light very high above the ground. And as the train continues through the darkness, invisible particles from the sun are meeting the most invisible part of Earth, the magnetic field surrounding the planet, where the meeting between star and sky begins to bend into shape. Earth's magnetic field, an invisible dome. The stream of particles from the sun has left its star, crossed the space between planets, and now approaches Earth. But Earth is not waiting for it with an empty sky. Before any particle can move deep into the layer of atmosphere where the aurora is born, it has already entered an invisible region surrounding the planet, a region the human eye cannot see, yet one that determines so much about the shape of light in the polar sky. If we looked at the planet only from far away, we might see white clouds curling over the oceans, darker continents, ice at the two poles reflecting light, and the thin atmosphere wrapped around the outer edge like a faint blue outline. But one part of Earth does not appear in that image. It reaches farther out than the atmosphere, surrounding the planet like a vast region of influence. It is not a dome made of matter, not a transparent layer of glass, and not a hard wall standing between Earth and space. It is an invisible field, softer than anything we usually call a shield, but important enough to change the path of charged particles arriving from the Sunday. In the northern night, no one feels the magnetic field on their skin. The person standing outside the station only feels the cold. The person sitting inside the train car only hears the steady sound of wheels on the tracks. Snow still rests quietly on the low rooftops, yellow lights still fall across empty roads, and the aurora still drifts very high above. Everything seems to belong to an ordinary night, except for that strange green color in the sky. But in that very silence, Earth's magnetic field is doing its work, so quietly that we only recognize it through the final result. Bands of light do not appear at random, but often gather near the polar regions. This is very important. If the solar wind simply poured straight into Earth, the aurora might not have the familiar shape we see. It might appear more chaotically, or create very different interactions across the atmosphere. But the magnetic field gives the meeting between the sun and Earth a path. It bends many particles from the sun away, preventing them from plunging directly toward the planet's surface. At the same time, it also guides part of that energy along curved routes toward the two polar regions, where magnetic field lines reach deeper into the upper atmosphere. We can picture, very gently, invisible curves surrounding Earth. They are not real lines like the railroad tracks beneath the train, but for charged particles, they matter almost like pathways. When particles from the sun enter this region, they no longer move as if space were completely empty. They begin to bend, spiral, and slide along magnetic structures that human eyes cannot see. A large portion is kept far from the places where humans live. Another portion can be guided toward the two ends of the planet, where the polar sky later lights up in very soft colors. That is why auroras often appear in the north and the south, rather than spreading evenly over every place on Earth. The polar regions are not special only because they are cold, because they have snow, or because their nights can be long. They are special because of the way Earth's magnetic field connects with the atmosphere there. The magnetic field lines seem to bend closer to the polar sky, opening pathways for energy from space to enter the very high layers of air above the ground. When conditions are right, these regions become the places where the sky is most likely to glow. Outside the train window, the passenger may see only a green band slanting across the horizon. But if we step back in imagination, that ribbon of light is no longer a single isolated streak. It is part of something larger, a glowing oval that can surround Earth's magnetic pole. From the ground, we see only a small piece of that structure, like standing very close to a large painting and seeing only one brushstroke passing before our eyes. On the scale of the whole planet, the aurora has its own map, and that map is shaped by the magnetic field. Saying this does not mean Earth's magnetic field is completely calm and unchanging. When the solar wind is gentler, the invisible region around the planet may be relatively stable. When the sun sends a stronger stream of particles, the magnetic field can be compressed on the side facing the sun and stretched out behind Earth, like an invisible tail in space. It responds, adjusts, vibrates, and sometimes stores and releases energy. Those changes are too distant and too vast for people on the ground to feel directly, but the polar sky can show signs of them by glowing brighter, moving faster, or expanding farther than usual. What is remarkable is that the magnetic field both protects and allows part of the connection to happen. If it were only a sealed wall, the aurora would have little chance to appear. If it did not exist, Earth would face the stream of particles from the sun much more directly. But reality lies between those two extremes. The magnetic field does not lock the planet away from the universe, and it does not let everything enter freely. It creates a buffer zone, a selective system, where most particles are deflected, while part of the energy is guided along its own paths toward the polar regions. There is a very quiet beauty in the way Earth responds to the sun like this. The sun sends out a stream of particles. Space carries that stream far away. Earth, through its magnetic field, does not simply stand still and endure the impact, but bends that meeting into an ordered shape. And when the particles are guided toward the high regions near the two poles, the atmosphere becomes the place that receives the final part of the journey. The light we see in the sky, then, is not a random accident, but the result of many layers of nature working together. An active star, a planet with a magnetic field, and an atmosphere thin enough in its upper layers to glow when it receives energy. In everyday life, human beings still have very small ways of recognizing the magnetic field. A compass needle turns toward a familiar direction. Some birds and living creatures may rely on the magnetic field to navigate during long journeys. Scientific instruments can measure how it changes over time. But to ordinary human eyes, perhaps the magnetic field is most beautiful when it does not appear directly, but leaves its trace through the aurora. We do not see the magnetic field lines, but we see where they guide energy. We do not see the invisible regions surrounding the planet, but we see the sky change color near the places where that region touches the atmosphere in its most special way. The band of light outside the glass may now be hanging down in a few thin folds. It looks like a curtain because the human eye needs a familiar image to name something so strange and distant. But inside each fold of light, there is the trace of pathways that cannot be seen. Particles from the sun do not simply choose any random place in the sky to glow. They are bent by the magnetic field towards certain regions, and only when they meet the right layer of air does light begin to appear. So the soft shape of the aurora is not only a matter of light, it is also the indirect shape of Earth's magnetic field, translated by the sky into color. If we think about this in the quiet of the night train, the aurora suddenly feels closer. It is no longer only a distant phenomenon of the polar regions, and no longer only a beautiful scene to photograph. It is a sign that this planet has a protective layer working at every moment, even when no one can see it. On days without auroras, the magnetic field is still there. On cloudy nights, it is still there. When humans sleep, when cities glow with lights, when the sea moves beneath the moon, when trains pass through cold lands, that invisible region still surrounds Earth and interacts with the stream of particles coming from the sunday. Perhaps that is why the aurora does not only make us look upward, but also makes us feel Earth in a different way. This planet is not a small, helpless point in space. It has a deep interior in motion, a magnetic field extending outward, an atmosphere wrapped around its living surface, and the ability to turn part of its meeting with the sun into light. All of this happens without sound, without needing human attention, without any warning. Then, on a night dark enough, in a place far enough from artificial lights, the sky lets us see a very small part of that quiet work. High above, the glowing band may be changing from a thin line into a wider arc. It does not explain why it is there, but its curve already carries the first answer within it. The aurora often comes to the polar regions because Earth's magnetic field guides energy there. It moves, bends, and changes because the meeting between the solar wind and the magnetic field is not still. It has shape because the light is not born in a chaotic emptiness, but within a structured system, even though most of that structure lies beyond our sight. The invisible particles have now traveled through the longest part of their journey. They have left the sun, crossed the emptiness of space, encountered the magnetic region around Earth, and some of them are being guided toward the polar atmosphere. There, the story no longer belongs only to outer space. It begins to enter the planet's thin layer of air, where oxygen and nitrogen can receive energy and return it as different colors. Above the snowy landscape, the sky is still drifting very slowly, but in the upper atmosphere, light is about to have a reason to be born. The invisible particles have reached the most delicate part of their journey. They are no longer only a stream of matter leaving the sun, and no longer only particles drifting through the space between planets. As they enter the magnetic region surrounding Earth, they begin to follow a different kind of order, as if the planet has its own pathways that do not appear to human eyes. And it is these pathways that explain why the aurora usually does not appear everywhere, but tends to gather near the two polar regions. This is very easy to misunderstand. The polar regions do not create auroras because they are cold. Snow does not make the sky glow. The long nights of the north or south only give humans more darkness for observing, like a stage dark enough for faint light to become clear. The real cause lies much higher, in the way Earth's magnetic field guides part of the energy from space down toward the uppermost layers of the atmosphere. If the magnetic field is the invisible dome around the planet, then the polar regions are where that dome has its most special curves. Magnetic field lines do not lie flat around Earth like evenly drawn circles on a map. They extend outward into space, curve around the planet, and then enter the atmosphere near the northern and southern ends. To human eyes, all of these lines are invisible, but for charged particles, they have a very real influence. When a particle from the sun enters the magnetic field, it no longer moves as if it were flying through a completely free emptiness. It is bent in direction. It may spiral around magnetic field lines, It may be guided farther away from the surface, or under certain conditions, it may slide along those pathways toward the polar regions. So the aurora is not a layer of light falling randomly down onto Earth. It has places where it appears more often, shapes that tend to repeat, and regions of the planet where it is easier to see than others. On a large scale, auroras often form glowing regions shaped like rings or ovals around the magnetic poles. A person standing on the ground sees only a very small part of that glowing region, a green arc near the horizon, a faint band above a dark forest, or a curtain of light opening direct parting, a verdun, a particles of recal, a particles arriving from the Sunday, but that moss piece belongs to a much larger structure, drawn by the magnetic field and by the stream of particles arriving from the Sunday. One important detail is that the magnetic poles and the geographic poles are not exactly the same. The geographic poles are related to Earth's axis of rotation, while the magnetic poles are related to the structure of the magnetic field. These two positions do not line up perfectly, and the magnetic poles can also shift over time. So when we say auroras often appear near the polar regions, it does not mean the light only circles the exact North Pole or South Pole on a map. It is usually connected to the regions around the magnetic poles, where magnetic field lines make it easier for particles to move down into the upper atmosphere. This detail helps explain why certain places have become famous for aurora viewing. High-latitude regions such as Alaska, northern Canada, Scandinavia, Iceland, Greenland, or areas near Antarctica, however, the aurora is not locked there. When the sun becomes more active and Earth's magnetic field is more strongly disturbed, the auroral region can expand. Places that rarely see auroras can sometimes catch a faint red glow, a weak green streak, or a strange light near the horizon. This makes the aurora both orderly and surprising. It does not appear completely at random, because the magnetic field has created favorable regions around the poles. But it is also not like a lamp switched on at a fixed time, because the strength of the solar wind, the direction of the interplanetary magnetic field, the state of Earth's magnetic field, clouds, artificial light, and the darkness of the sky can all change the experience of the observer. There are nights when everything on the ground seems perfect, yet the aurora appears only very faintly. There are other nights when the sky unexpectedly opens into many bands of light, as if the polar region has received a stronger breath of energy from space. It is this changing nature that makes the aurora feel like a living phenomenon. A glowing arc may begin low near the horizon, very dim, almost uncertain to the eye. Then it may brighten, rise higher, split into several layers, or hang downward in vertical streaks like folds of light. As the energy entering the atmosphere changes, the shape of the aurora changes as well. We are not watching an object drifting across the sky. We are watching a region of the atmosphere glow, while it is continuously energized by particles from space. That is why the image of an aurora curtain is both visually fitting and easy to misunderstand if we imagine it as a real object. There is no curtain hanging in the sky. There is no green fabric moving in the wind. Those folds of light appear because particles move downward along the structure of the magnetic field, meet the atmosphere at different regions and heights, and create glowing areas that change over time. From the ground, the human eye gathers all of this into a soft image. Behind that image are the paths of charged particles and the way Earth guides them toward the two poles. The northern lights, often called the aurora borealis, are the image most familiar in many people's imagination. But on the other side of the planet, the southern lights, or aurora australis, appear according to the same larger principle. Both hemispheres can have auroras because both are part of Earth's magnetic field system. A stream of particles from the sun does not create only one story in the north. It can make both ends of the planet glow in different regions, depending on how energy enters the system. From the ground, humans usually see only their own sky. On the scale of the planet, the aurora is more like a wider response, happening around the two regions where the magnetic field guides energy down into the atmosphere. But whether it is called the northern lights or the southern lights, the aurora still needs one very simple thing for humans to see it: darkness. Its light can be much weaker than the brilliant photographs we see on screens. In the polar regions, long winter nights give the eyes time to notice faint streaks of light. Clear skies keep clouds from hiding the glowing upper atmosphere above. Places far from city lights prevent faint green or red colors from being drowned out by artificial light. These things do not create the aurora, but they give the aurora a chance to be seen with the naked eye. So the cold and the long night are not the cause, but the setting. They are like silence before a very soft sound can be heard clearly. If the city is too bright, if clouds cover the sky, if the human eye has not had time to adjust to the darkness, the aurora may still be happening above us without being noticed. This makes the phenomenon even more subtle. It does not only need to be created by the sun, the magnetic field, and the atmosphere. It also needs to be seen under conditions quiet enough for humans to detect it. By now, the picture has become clearer, but it has not closed. The sun sends out charged particles. Space carries them toward Earth. The planet's magnetic field does not let them fall everywhere, but bends them along invisible pathways toward the polar regions. Those regions become the places where auroras often appear, not because they are colder or more mysterious, but because they lie near the natural entryways for energy from space. The remaining question lies in the next moment. Once the particles have been guided to the polar regions, they still have not become light. They need to meet Earth's thin air, where oxygen and nitrogen quietly exist at very high altitudes. A single collision there creates nothing significant to the human eye, but countless collisions, spread across a wide region, can turn the upper atmosphere into a soft source of light against the night. And that is where the aurora comes closest to the human eye. It is no longer only the solar wind moving through space. It is no longer only the magnetic field bending invisible particles toward the poles. In the upper atmosphere, those particles finally meet the matter of Earth. They meet oxygen. They meet nitrogen. They meet a layer of air too thin for humans to live in, but real enough to release light. From a colorless, silent, shapeless stream of particles, the sky begins to prepare the colors we call the aurora. After being guided by the magnetic field toward the polar regions, the particles from the sun still have not become light. They have traveled a very long way, crossed the space between planets, entered the invisible region of influence around Earth, and followed pathways that human eyes cannot see. But up to this point, everything still belongs to the world of the invisible. No green color appears the moment the particles come near the planet. No curtain opens by itself simply because the solar wind has touched the magnetic field. The aurora only begins to appear when that journey meets something deeply familiar to human life, but in a place far stranger than any breath we take on the ground, the thin layer of gas very high above Earth. Down below, air is so familiar that it is almost forgotten. It is in every breath, in the sound of wind sliding over rooftops, in the scent of cold snow, in the mist clinging to window glass, in the quiet movement of leaves as night falls. We live inside it, depend on it, yet rarely think of air as part of a cosmic story. The higher we go, that familiarity gradually changes. The air does not stop at a clear dome, and it does not end at a sharp boundary, where Earth lies below and empty space begins immediately above. It thins out slowly, layer by layer, altitude by altitude, until the molecules become so sparse that the distances between them are far greater than anything we can intuitively feel. It is in this transition region that the aurora finds the place where it can be born, not near the ground, where humans stand beneath the snow and look up, not among low clouds, where everyday weather usually happens, and not in the completely empty space between planets. The aurora belongs to a very high layer of the atmosphere where Earth's oxygen and nitrogen are still present, but the air has become far too thin to resemble any atmosphere we have ever breathed. It is the planet's delicate edge, a region that still belongs to Earth while also opening itself to the influence of space. If the earlier part of the story showed why particles are often guided toward the polar regions, the question here becomes smaller, closer, and more delicate. When those particles truly meet the atmosphere, what happens that allows darkness to begin taking on color? This is the moment when the story leaves behind invisible magnetic field lines and enters the world of oxygen, nitrogen, energy, and light. A charged particle rushes into the thin upper air. It meets an atom or a molecule along its path. That encounter is too small to make a sound, too small to resemble a collision in the everyday sense. But it is enough to transfer part of the particle's energy into the inner structure of the gas. We might think of a very small bell sitting in silence. If nothing touches it, it releases nothing. But when it is gently struck, it vibrates, holds energy for a moment, and then gives that energy back as sound. With oxygen and nitrogen in the upper atmosphere, the comparison is not physically exact, but it helps us feel the rhythm of the phenomenon. The particles from the sun do not make the gas burn like fire. They transfer energy. The atoms and molecules receive that energy, enter an excited state, and then, as they return to a more stable state, they release the extra energy as light. One collision like this does not create an aurora. One single photon of light does not make the whole sky change color. But nature does not work on the scale of a single particle alone. Across a wide region of the upper atmosphere, countless particles enter, countless atoms and molecules are excited, and countless photons are released. These tiny events join together into a band of light wide enough for someone standing far below to see. From the ground, we do not see the collisions. We do not see each individual photon. We see only the final result, softer and more continuous, as if the sky were pulling a colored silk ribbon through the darkness. That is why the aurora can so easily mislead our senses. To the eye, it looks like an object, a curtain, a river of light, an arc of color drifting through the night. But in reality, it is not an object hanging overhead. If we could fly to the exact place where that light is being created, we would not touch a green curtain. We would pass through an extremely thin region of gas, where the process of glowing is happening at countless tiny points. The aurora is a phenomenon, not a thing. It is more like music than an instrument, more like the luminous trace of a process than something with a fixed shape. This difference is what makes the aurora both easy to see and difficult to understand. The human eye likes to gather things into familiar forms. A long band of light looks like a curtain. A curved glow looks like a river. Vertical streaks hanging downward look like folds of fabric. But behind those images is a more delicate truth. The atmosphere is glowing unevenly, in different regions, at different moments, depending on where the particles enter and how energy is exchanged. When one region glows more strongly, we see a fold appear. When another region fades, the curtain seems to dissolve. When the particle flow changes, the shape of the light changes with it. This also explains why the aurora appears to be moving, even though there is no real curtain flying in the wind. Particles from space are continuously entering along different paths. The magnetic field shifts slightly under the pressure of the solar wind. The upper atmosphere is not a perfectly even background. More energy is delivered to one place, less to another. As a result, the glowing region in the sky can expand, shrink, brighten, fade, or divide into soft folds. A viewer on the ground sees that motion as a slow drift of light, while science sees a process changing in real time. There is a strange beauty in this. The aurora is not created by large, noisy events, but by countless events, so small that they cannot be sensed directly. One particle gives energy to one atom. One atom returns that energy as one photon. One photon travels down through the darkness. Then many photons arrive together at the human eye. In that moment, the entire polar sky seems to be built from very small exchanges, so quiet that no sound comes with them, yet numerous enough to become a sight that can make a person stand still for a very long time in the cold night. Oxygen and nitrogen are the two most familiar names in this story, but they should not be thought of as simple colors poured across the sky. They are components of the atmosphere, and each gas has its own way of receiving and releasing energy. Oxygen can be connected to the green light we see so often, and sometimes to red light at greater heights. Nitrogen can contribute shades of blue, purple, or pink in other parts of the glowing display. But before we go deeper into that palette, the more important thing is to feel the general principle. The colors are not painted on from outside. They are emitted by the atoms and molecules themselves as they release energy. In other words, the aurora is not a picture projected onto the sky. It is more like a voice of the atmosphere. When there is no stream of particles from space, that high layer of air is still there, thin and almost invisible. When energy arrives, part of the atmosphere answers with light. Each kind of gas answers in a different way, at a different height, with a different color. The polar night, then, does not simply become bright. It glows in the private language of oxygen and nitrogen. From the ground, that truth comes to us slowly. A person standing outside does not think about atoms while looking at the aurora. They see the color first, and only later can they learn how to understand that color. They see the softness first, and only later discover that behind it are particles, magnetic fields, and the atmosphere. That does not make the experience less natural. On the contrary, it is like hearing the sound of an instrument before knowing how its strings vibrate. Beauty comes first, knowledge comes afterward. And when knowledge arrives at the right pace, it does not break the beauty. It makes the sound deeper. At the altitude where the aurora is born, there is no observer standing nearby to hear or directly see each tiny event. Everything is sent downward as light. Photons leave the upper atmosphere, pass through thinner layers of air, cross the darkness, and finally touch human eyes on the ground. In that moment, a very small event at the edge of space becomes a deeply human experience. Someone lifting their head, a pair of eyes slowly adjusting to the night, a feeling of silence as the sky changes color. The aurora therefore connects scales that seem impossible to bring together. A tiny oxygen atom, a charged particle from the sun, a magnetic field line surrounding the planet, a thin layer of atmosphere at great altitude, a human being standing below, seeing all of it only as a band of light drifting overhead. No part of that chain looks like any other, yet they all take part in a single phenomenon. And that phenomenon only appears fully when we see it from far away, in darkness, with enough patience for faint light to become meaningful. If we look closely, we can see that the aurora is not only light, but transformation. Energy leaves the sun as the motion of particles. Earth's magnetic field bends their path toward the polar regions. The atmosphere receives that energy through tiny collisions. Then the energy is returned as photons, as color, as a glowing band. No single step is enough to create the whole beauty. Only when the steps connect, from star to planet, from particle to atom, from atom to human eye, does the aurora appear as something continuous. Here, the story has come closer to the heart of the phenomenon than ever before. It is no longer only the sun sending particles. It is no longer only the solar wind crossing space. It is no longer only the magnetic field guiding particles toward the poles. Now, we have reached the moment when energy touches the atmosphere and is changed into light. But that light does not have only one color. It is not always green, even though green is the image many people remember most clearly. There are red auroras very high above purple or blue edges lower down, and thin shades of pink that may appear clearly only in photographs or on especially rare nights. Each color is a clue. It tells us which gas is glowing, at what altitude, and under what energy conditions. The common green color is not accidental. It comes from a very particular kind of response from oxygen in the upper atmosphere, where atoms receive energy and then emit light at a wavelength the human eye can see quite well. To understand why that green becomes the most familiar face of the aurora, we need to stay a little longer with oxygen, a gas that is familiar in every breath, but high in the sky can turn the night into a gentle river of light. Oxygen is a very familiar name, so familiar that in everyday life we almost stop noticing how strange it really is. It enters the body with every breath, quietly taking part in the life of plants, animals, human beings, small flames, wide oceans, and the ordinary rhythm of a day on Earth. But when that same kind of atom appears very high in the atmosphere, far from the ground, far from warm breaths and houses glowing with light, it can do something entirely different. It can emit the gentle green color that people often remember first when they think of the aurora. That green is not painted onto the sky like color on fabric. It is also not green light from the sun traveling straight to Earth and becoming trapped in the air. It is oxygen's response after receiving energy from particles arriving from space. Earlier, we reached the most important moment of the phenomenon. A charged particle, guided by the magnetic field toward the polar region, rushes into the upper atmosphere, collides with an atom or molecule, and transfers part of its energy to it. When that part of the gas returns to a more stable state, it releases the energy as light. With oxygen, under very common aurora conditions, that light often falls in the green range, which the human eye can recognize fairly well in darkness. This makes the green of the aurora both familiar and distant. Familiar, because it appears so often in images of the northern and southern skies. Distant, because that color does not come from anything green we can hold in our hands. Not leaves, not seawater, not the neon light of a small street sign. It comes from an energy state of oxygen atoms occurring at great altitude, where the air is too thin for humans to live, yet still real enough for tiny collisions to form a wide band of light. We can imagine oxygen in the upper atmosphere as very quiet notes of music. Normally, they make no sound and show no color to the human eye. But when a particle from the sun touches them and transfers energy, that note is lifted. It vibrates for a moment in its own atomic way, and then, as it returns to a lower state, it emits a color. For one very important transition in oxygen, that color is green. Not a harsh, dazzling green, not the green of a bright sign, but a kind of green that can look very soft after passing through the atmosphere and being seen from the ground at night. Green becomes common because several reasons come together. Oxygen is present in the upper atmosphere in the regions where auroras often occur. The energy of the incoming particles is often suitable for exciting oxygen in a way that produces green light. And the human eye, even though it does not see color very well in darkness, can still recognize green more clearly than many other faint shades. So when an aurora is bright enough to appear, green is often the first color people notice, the color easiest to remember, and often the color that makes them realize what is drifting across the sky is not cloud. However, the green of a real aurora does not always look like the green in a photograph. In a long exposure image, a camera can gather more faint light than the human eye, making the green appear thicker, brighter, almost glowing across the entire frame. Under the real sky, that same aurora may be softer, thinner, sometimes only a very light gray-green glow along the horizon. Some people see the color clearly, others see only a pale streak, and then, when they look back at a photo, they realize the green was there more strongly than they thought. This does not make the aurora any less real, and it does not make the photograph false. It simply shows that the human eye and the camera receive faint light in two different ways. In darkness, the human eye shifts into a mode that is more sensitive to brightness than to color. The rod cells in our eyes help us detect shapes in low light, but they do not distinguish color as well as the cone cells that work better in stronger light. Because of this, a weak aurora may appear to the human eye as almost gray-white or only faintly green, while a camera can still record a clear green color. When the aurora grows stronger, the green becomes easier to see with the naked eye. This is why the real experience of the aurora is sometimes more subtle than photographs suggest. but also why it has its own quiet closeness. It does not always arrive with brilliance. Sometimes it asks the viewer to slow down, let the eyes adjust to the dark, and only then notice the green slowly revealing itself. Green auroral light is often produced at an altitude of a little over 100 kilometers above Earth's surface, in a region of the atmosphere where there is still enough oxygen for collisions to happen, but where the air is far thinner than it is on the ground. This altitude matters because it creates a delicate balance. If the process happens too low, collisions between gas molecules can cause energy to be lost in other ways before the light can be clearly emitted. But at the right height, oxygen has time to release energy as green photons, and that light can travel down through the atmosphere to reach human eyes. We do not need to remember the exact number to feel what this means. We only need to know that the aurora's green is created in a very high region, where the atmosphere still belongs to Earth, but is already much closer to space than to everyday life. What is beautiful here is that oxygen is still oxygen, but its surroundings have made it seem different. Near the ground, oxygen helps fire burn, supports life, and passes through human lungs with every breath. In the upper atmosphere, it becomes part of the polar display of light. The same familiar element, at different altitudes and under different conditions, tells different stories. This makes the aurora feel far less alien. The green in the sky is not made from some mysterious substance arriving from outer space. It is created by a very familiar part of our own planet. Only that part is in a place everyday life cannot reach. When a green aurora opens across the sky, it does not glow evenly like a luminous sign. Some sections are thicker, some are thinner, some bright regions slowly spread outward and then soften again. This happens because energy does not enter the atmosphere in a perfectly even way. The particles are guided along the magnetic field, gather in certain regions, change over time, and meet gas at different altitudes and densities. Where oxygen receives more energy, the light may grow brighter. Where the particle flow weakens or shifts direction, the green fades. From the ground, that variation becomes the soft motion of the aurora, as if the ribbon of light is breathing in and out very slowly. Sometimes the green lies low near the horizon, only a faint arc stretching across the distance. Sometimes it rises higher, opening into folds of light in the sky. Sometimes those folds stand almost upright, creating the feeling of a curtain hanging down. But even as the shape changes, the mechanism keeps one common thread. Oxygen in the upper atmosphere is being excited and emitting light. Whether that light arranges itself into a band, an arc, or a curtain depends on the path of the particles, the shape of the magnetic field, and the distribution of the atmosphere, not because there is a green object flying through the sky. The green also helps us understand why the aurora is both a phenomenon of Earth and a phenomenon of space. If there were only oxygen, but no energy from particles arriving from the sun, the polar sky would not glow this way on its own. If there were only particles from the sun, but no atmosphere, there would be no oxygen to emit green light. If there were no magnetic field guiding some of those particles toward the polar regions, the energy would not be concentrated in the way that creates those familiar glowing bands. So a green color that seems simple actually needs at least 3 layers to meet. The sun sends particles, Earth bends their path with its magnetic field, and the atmosphere answers with light. That cooperation makes the green of the aurora different from the green of an object already present in nature. Leaves are green because of the way pigments absorb and reflect light. The ocean can look blue-green because light interacts with water and because the sky is reflected on the sea's surface. A green lamp glows because electricity activates a source inside it. But the aurora is green because oxygen high in the atmosphere releases photons after receiving energy. 4 shades of green may look similar to the human eye, but the paths that create them are different. The aurora, then, is a gentle reminder that the same color can have many different origins in nature. Sometimes the green does not appear alone. Above the green band, if conditions are right, a very high, faint layer of red may appear. Along the lower edge or the rim of the display, there may be shades of purple, blue, or pink contributed by nitrogen. But green often remains the familiar foundation, like the main voice of the Aurora's music. It is the color many people see first, the color that makes photographs of polar skies easy to recognize, the color that gives the feeling that a soft current of light is passing through the night sky. There is another reason green has become the symbol of the aurora. It lies in a range that the human eye can perceive relatively well when the light is strong enough. High red light can be very beautiful, but it is often fainter to the naked eye, especially in dark conditions. Purple or blue tones may appear, but the human eye can easily miss them if the aurora is weak. A camera may preserve them more clearly. Green, in many cases, is bright enough and well suited enough to human vision to become the main color in memory. When someone says they have seen the aurora, the first color they often remember is that green. But this should not make us think the aurora is always green and only green. Every appearance carries the conditions of that particular night. Whether the sun is sending a strong or weak particle flow, what direction the magnetic field is taking, at what altitude the particles are entering, what state the atmosphere is in, and how dark the sky is for the eyes looking upward. There are nights when green is all that appears clearly. There are nights when green is only the lower part of a more colorful structure. And there are nights when the aurora is so weak that the green is almost hidden inside gray, revealing itself only through a photograph or after the eyes have adjusted to the darkness. This gives aurora watching a very different rhythm from looking at a lamp. With a lamp, we know what color it has once it is switched on. With the aurora, color can unfold gradually. At first, there may be only a faint streak of light. After a while, the eyes begin to separate out the green. Then, in another region, the color may become thicker, deeper, or gain a very slight purple edge. The viewer is not only observing light, they are learning how to let darkness reveal the light. The green of oxygen, therefore, does not arrive like a hurried answer, but like a detail slowly appearing when we become quiet enough to notice it. If there is one thing to keep in mind about the green of the aurora, it is that it is not decoration on the sky. It is the sign of a very specific process. An oxygen atom in the upper atmosphere receives energy. It holds that energy for a moment. Then, as it returns to a more stable state, it emits green light. One atom doing this is far too small to see, but many atoms across a wide region create the band of light that humans can see from the ground. From a small event to a large scene, the aurora always works in this way. Many things too tiny to see come together into a beauty large enough to change the sky. And perhaps because oxygen is so familiar, the green of the aurora carries a very special feeling. It is not completely alien, like light from another world. It is also not completely ordinary, like a streetlight below. It exists somewhere in between, made from the material of Earth, but awakened by energy from the sun, appearing within the atmosphere of the planet, but only in a very high place, near the edge of space, visible to human eyes, but born from energy, changes inside atoms. That green is like a very delicate bridge between the familiar and the distant. When we look at a green aurora, we are seeing the atmosphere no longer as the transparent background behind life, but as an active part of the sky. It does not merely allow light to pass through, it glows by itself. Oxygen, normally colorless around us, becomes a source of color under special conditions. This makes Earth feel more alive, not in a biological sense, but in the sense that the planet has layers that respond delicately to space. The sky is not a passive dome. It is a region participating in the meeting between star and planet. At the edge of that green band, the question of color is not finished. Oxygen can create the familiar green, but it does not have only one way of glowing. At greater altitudes, in thinner conditions, it can create a very different red, slower, fainter, sometimes spreading like a high layer of light above the green curtain. Nitrogen has not yet fully entered the story either. The purple, blue, and pink shades along the edges of the aurora are often connected to it, and they make the palette of the polar sky far richer than a simple green band. So green is the first doorway, not the entire room. It shows us that oxygen can turn energy from space into light that human eyes can recognize. But above it and around it are other colors, other signs, other ways the atmosphere can answer. When the polar night opens into more than one shade, we begin to read a deeper part of the phenomenon. Each color is a clue to the altitude, the type of gas, and the energy of the particles that have traveled the long journey from the sun to Earth. As the green of oxygen gradually spreads across the sky, the observer may begin to notice other faint shades along the edges of the glowing band. Those soft hints of red, purple, blue, or pink do not all appear at once, but they make the sky feel more layered, more fluid, and more alive. This is the subtle role of nitrogen, a familiar component of the air, but in the upper atmosphere, it becomes a quiet artist, contributing tones that the human eye can hardly forget. Each color in the aurora tells its own story. When particles from the sun are guided by the magnetic field toward the polar regions, they collide with gas molecules in the atmosphere. Oxygen often emits green light, but nitrogen, with a different energy structure, can create shades of purple, blue, or pale red, depending on altitude and the amount of energy the charged particles deliver. On a night beneath the sky, green may dominate, but if we look carefully, the edges of the glowing band may reveal other colors, like faint notes drifting above the main melody. Purple and blue shades often appear along the edges, where less energy may be entering or where the air is thinner. They move with the same green band, curving, stretching, and sometimes hanging downward, giving the sense that the aurora is breathing in the night. Each gentle shift is the result of millions of tiny collisions, producing no sound, no smoke, and no cloud, yet enough to form layers of color resting over one another. A person standing below may see soft folds of light bending with the motion of particles in the atmosphere, but the deeper reality is a chain of atomic encounters happening millions of times. Red often appears higher up, where oxygen is more spread out and nitrogen is still present. On nights when the sun is especially active, when the stream of charged particles carries more energy, high and faint red tones may open above the green layers, forming stacked sheets of light that stretch into broad arcs across the sky. These colors can be difficult to recognize with the naked eye if the light is not strong enough, but they make the scene feel deeper and richer. A sensitive observer may notice the delicate mixture of green, purple, blue, and red, creating a symphony of light prepared by nature through millions of tiny collisions. Nitrogen can also create pale pink tones and different shades of purple along the edges of the aurora. These colors often appear in regions where the particle flow is weaker, or where collisions occur in thinner air, causing the emitted light to be lower in intensity, yet still visible across the night sky. The combination of oxygen and nitrogen, together with different energy conditions, gives the auroral band both depth and softness, making the human eye feel that the aurora is not only light, but almost like a living presence moving gently. The constant change of these colors also creates the aurora's own rhythm. A green arc may stretch outward, a high red streak may separate and slowly fade, a purple or blue region may bend along the glowing band. Each change reflects the distribution of energy in the atmosphere and the way the magnetic field guides particles into different regions. To someone standing below, the whole thing looks like a soft curtain, but in reality, countless tiny collisions are unfolding according to an order that is not entirely random. One aurora night may be different from the night before, even in the same season and in the same place. Each time the sun sends out a wind, each time Earth's magnetic field adjusts the path of the particles, and each small change in the density of the upper atmosphere contributes to the color and shape of the glowing band. That is why no two auroras are ever exactly alike. Their colors, motion, altitude, and spread all carry the traces of the specific conditions of that moment, making the phenomenon feel alive and always new to the observer. Green may remain the main color, but red, purple, blue, and pale pink are important supporting notes, allowing the observer to sense more layers and more depth. Each color is a clue to the atmospheric layer where it was born, the type of gas involved, and the amount of energy transferred by the charged particles. When the human eye looks at an auroral band, we are seeing oxygen and nitrogen working together, returning energy from space as light in a subtle way that nature has arranged. These colors are also one reason the aurora appears to be moving. When one region of gas responds first, light appears there. When another region responds afterward, light follows. The colored bands overlap, change shape, expand, narrow, twist, or hang downward. All of this happens slowly and continuously, giving the observer the feeling that the aurora is breathing, while in reality, countless atoms and molecules are glowing according to physical laws. This soft rhythm creates the gentle, dreamlike beauty of the aurora, enough for someone standing beneath the sky to let go into the quiet and simply watch. Because of this combination of oxygen and nitrogen, the colors of the aurora are never monotonous. One night may open mostly in green, with a faint purple rim and a thin blue edge. Another night may bring a high red glow, forming several stacked layers, like delicate curtains of light hanging down through the sky. This richness makes the aurora both a scientific phenomenon and a softly visual experience, holding the observer's gaze upward until almost everything else in the cold night fades away for a moment. With this blending of colors, the aurora becomes a composition of light, where every shade has its own place, rhythm, and height. The observer does not need to understand the physics in order to feel its beauty. They only need to stand still, breathe slowly, and let their eyes follow the greens, reds, purples, blues, and pale pinks as they appear and disappear, drifting across the northern or southern sky, creating an experience that is soft, deep, and difficult to forget. During an aurora night, color is the story the atmosphere tells through light, and oxygen and nitrogen are the storytellers. They respond, release energy, and create the rhythm, layering, and softness that the human eye can see. And when we observe carefully, we realize that green is not the whole story, but only the most prominent part of nature's delicate symphony. In the middle of an aurora night, there is a moment many people have experienced. The sky in front of them does not quite look like the photographs they saw before the trip. High above, the band of light is real. It is still moving. It is still opening into a very soft green, but in real life, it may be thinner, gentler, sometimes almost blending into the gray of the darkness. Then, as soon as they set up a camera and hold it still for a few seconds, that same sky appears on the screen with a deeper green, clearer purple edges, and sometimes even a faint layer of red that the naked eye did not quite notice a moment before. That difference can easily be confusing. Is the camera exaggerating the aurora? Is the real scene outdoors less beautiful than what we see in photographs? Or is there a part of the color truly existing high above, while human eyes in the dark are simply not sensitive enough to hold on to all of it? This question connects very naturally to the aurora's palette. Oxygen can emit green light, and sometimes red at higher layers. Nitrogen can contribute purple, blue, and pink in other regions of the glowing display. But the creation of color in the atmosphere is one thing. How clearly the human eye receives that color is another. Auroral light is often much weaker than the light sources we know in everyday life. It is not like a street lamp, not like a phone screen, not like bright moonlight on snow. Many times, it is only a thin layer of light resting against the sky, enough for a patient observer to realize the sky is changing color, but not strong enough for every shade to appear clearly to the eye. In darkness, our eyes do not work the way they do during the day. As light decreases, the body prioritizes the ability to detect shapes and brightness rather than color. We see outlines, we see motion, we see which areas are brighter than others, But faint colors, especially weak red or purple, can slip into the darkness before we have time to name them. A camera has a different kind of patience. It does not look at the sky as a continuous stream of passing moments. When the photographer allows the camera to expose for several seconds, the sensor gathers light throughout that entire interval. Weak photons from the upper atmosphere, instead of touching the eye and disappearing in an instant, are accumulated on the sensor. A thin green becomes clearer. A purple edge that was very hard to see may appear. A high red layer, so faint that the human eye misses it, may sometimes be held by the camera as a soft veil of color above the green band. The camera is not inventing those photons, it is simply waiting for them longer. We might imagine this difference through a very quiet sound in a silent room. If we only listen for a moment, we may not be sure we heard anything at all. But a sensitive recording device, placed there for a few seconds, can preserve vibrations that the human ear missed. The aurora is similar. The human eye lives in real time, always seeing the sky as a moving flow. A camera accumulates light, turning weak signals into a clearer image. One gives us the feeling of standing beneath the phenomenon. The other reveals details that the direct moment may not be able to hold. That is why vivid aurora photographs are not necessarily fake, but they are also not exactly the same as what the eye experiences. They are records of light gathered over time. When a photo uses a long exposure, colors can appear thicker, brighter, even more brilliant than the sky felt to the person standing there at that moment. If saturation or contrast is increased afterward, the distance between the photo and the real experience becomes even greater. Even so, the real aurora does not become less valuable because of that. It is simply beautiful in a different rhythm, slower, more subtle, and asking the viewer to remain with the darkness a little longer. Someone who has just stepped out from a place filled with strong lights will often see very little. Their eyes are still adjusted to a phone screen, to car headlights, to the bright window of a nearby house. At that moment, the sky may look like an ordinary patch of darkness, even though a faint aurora is already present above. Only after standing still for a few minutes, avoiding strong light, do the eyes begin to open to the night. Fainter stars appear. The horizon becomes less flat. A very soft glow to the north begins to separate itself from the background sky. Then, gradually, green may appear, not like a loud call, but like a secret just clear enough to be recognized. In the direct experience, that waiting is a very important part. A photograph gives us the result quickly. A frame appears, the colors have already been gathered, the scene has already been held still, but the human eye has to move with the phenomenon. We look at a faint band of light, then see it rise slightly. We think it is about to vanish, and then another edge grows brighter. We are not sure whether that purple is really there, until it stretches along the green rim and quietly disappears. A camera can preserve color, the human eye preserves change. And with the aurora, change can be just as important as color. There are nights when the camera almost becomes a translator for the sky. It tells us that within a streak of light that seemed only pale green, there was also a very thin layer of pink. It pulls a little high red out of the darkness. It helps reveal blue or purple edges that the naked eye only sensed as a glow without a clear color. But there are also things a camera cannot preserve in the place of human sight. It cannot hold the cold on the face, the silence of a group of people standing outside, or the feeling when everyone lifts their heads at the same time and no one wants to speak loudly. It cannot hold the moment when a band of light suddenly moves faster, making the whole sky feel as if it has a pulse. A photograph keeps the image, memory keeps the time. So when we compare the aurora in photographs with the aurora in real life, we should see them as two ways of meeting the same phenomenon. The photograph is not a deceiver, and the human eye is not a poor instrument. They are simply different. The human eye was made to live in a moving world, to recognize change, distance, rhythm, and presence. The camera was made to hold light, stretch a moment, gather weak signals, and make them clearer. The aurora lies between these two ways of seeing, both a scene to be experienced and a light that can be recorded through technique. This difference becomes even clearer when we remember the roles of oxygen and nitrogen. The green light from oxygen is often the easiest to see because it fits relatively well with what the human eye can detect under conditions that are dark enough and bright enough. Higher red light may be fainter and harder to recognize, especially when the aurora is weak. The purple, blue, or pink tones contributed by nitrogen sometimes appear along the edges of the glowing display, where the intensity is not strong. A camera, when set up properly, can gather those colors and show them more clearly. The human eye, meanwhile, often notices the larger structure first, a band of light, a faint arc, a gentle motion, and only afterwards slowly begins to separate the colors. This does not take away from the truth of the experience. On the contrary, it makes the aurora feel closer to being human. We are not perfect sensors. We look at the sky with eyes that have limits, with a body feeling the cold, with excitement, with expectations shaped by photographs we have seen before, and with our own patience or impatience. One person may remember the aurora as a very faint green band filled with quiet. Another, after looking back at the photograph, may remember it as a more colorful sky. Both memories contain their own part of the truth. There are also nights when the aurora is strong enough that the gap between the photograph and the human eye becomes smaller. When the sky brightens clearly, the green appears to the naked eye. The folds of light move more quickly, and sometimes red or purple becomes strong enough to recognize without a camera. In those moments, the person standing beneath the sky feels that the photograph is no longer doing very much work for them. Their own eyes have caught most of the scene. But nights like that do not always arrive. Much of the time, the aurora keeps a more delicate beauty, and the camera becomes a way for humans to read additional layers of color hidden in the darkness. There is a small but memorable detail. Sometimes the camera makes the sky look more vivid, but it also loses some of its fragility. In a photograph, a weak band of light can become a striking green curtain. In real life, it is precisely because it is faint that the viewer has to stand still, has to watch longer, has to distinguish it from cloud, and has to feel the joy of seeing it move. That experience is very difficult to replace with a perfect photograph. The beauty is not only in the final color, but also in the process of recognizing that color. In real life, the aurora is sometimes more like a whisper than a grand song, and to hear that whisper, the night has to become quiet enough. The polar sky also teaches us something gentle about seeing. Not everything beautiful appears immediately at its highest brightness. Some lights need darkness in order to exist in the human eye. Some colors need time to reveal themselves. Some movements only become clear when we stop searching for a brilliant spectacle and begin paying attention to smaller changes. When a camera gives us a more colorful version, it expands our vision. When the human eye looks directly, it preserves the slowness of the phenomenon. One makes things clearer, the other makes them deeper. From a scientific point of view, the difference between the eye and the camera is also a reminder that observation is never completely separate from the tool used to observe. When humans had only the naked eye, the aurora was a mysterious sight in the sky. With cameras, faint colors became easier to preserve. With satellites and sensors, the aurora is no longer seen only from the ground, but also monitored as part of the space system surrounding Earth. Each tool opens another layer, but no layer erases the one before it. The human eye still matters, because it is where the aurora becomes an experience. The camera matters, because it preserves what the experience may miss. Science matters, because it connects both of them to a deeper cause. A beautiful photograph of the aurora can make people want to search for the phenomenon. But once they are truly standing beneath the cold sky, they often realize that what they are seeking is not only color. It is the feeling of waiting in the darkness, looking at a streak of light that may or may not be real, and then gradually seeing it become clearer. It is the moment when the camera on the tripod reveals that the sky contains more color than the eye has just seen. It is the difference between seeing with the body and seeing with a sensor. And between those two ways of seeing, the aurora does not lose its beauty, it gains depth. When we understand this, we can become gentler toward vivid photographs and toward very faint aurora nights alike. A photograph may show us more colors, but the real sky gives us presence. A faint green band in real life is not less valuable just because a photograph makes it look brighter. A red layer in a photograph is not necessarily imagined just because the human eye did not see it clearly. Both speak of a real phenomenon, recorded through two different rhythms of time, the living rhythm of the human eye and the accumulating rhythm of the camera. And from that difference, the story of the aurora begins to widen into the way human beings have learned to observe the sky. Not only with eyes standing beneath the cold night, not only with cameras gathering light for a few seconds, but also with instruments that monitor the sun, sensors that measure the solar wind, stations that observe the magnetic field, and satellites that look down on the polar regions from space. If the human eye gives us the moment, and the camera gives us memory, then science gives us the path toward understanding why that moment happens. The greens, reds, purples, and blues in the sky, then, are not only beauty to be admired, they are nature's very soft data, signs that humans have gradually learned to read over many generations. From ancient people who saw the aurora as heavenly fire or spirits in the darkness, to modern scientists measuring each change in the solar wind, that journey reveals something beautiful. Human beings do not only stand beneath the sky in wonder. We also learn to listen to the sky, record it, compare it, and slowly understand that every glowing band above carries news from a distant meeting between the sun and earth. The first moments of green auroral light from oxygen gradually blend into the motion of the glowing band, but sometimes the human eye has not yet caught the whole story. Above it, the purple, blue, and pale pink edges of nitrogen begin to appear, gliding along each curved fold of light, creating a soft scene that the eye needs time to follow. The direct experience is different from a photograph. The human eye records rhythm and gradual change, while a camera gathers photons and displays the full range of color almost at once. This is where nature and human observation meet, where each layer of color and each movement carries its own distinct feeling, close, gentle, and dreamlike. Each layer of light is the result of countless small collisions between particles from the sun and atoms in the upper atmosphere. Oxygen remains the familiar green tone, while nitrogen adds purple, blue, or pink, creating a symphony of light. No single collision is enough for the eye to notice. Only when millions of collisions happen at the same time does a soft band of light appear, wide enough for the human eye to follow and feel. This continuous rhythm makes the aurora seem as if it is breathing in and out, even though each photon moves according to precise physical laws. The motion of the aurora is not even. A green band may stretch outward, curve, then suddenly fade at one end and brighten at the other. The colored edges following behind create the feeling that the aurora is weaving a soft curtain. A faint red layer appears high above, sometimes interlacing with green and purple, making the sky look like a piece of music made of light. The differences in color, altitude, and motion create a layered experience for the observer, making each moment beneath the polar sky feel unique. Although the aurora seems to move smoothly, behind it is a complex system. Particles from the sun, bent by Earth's magnetic field, colliding with oxygen and nitrogen at different altitudes. The upper atmosphere is not uniform, its density varies, and the light it emits is not evenly distributed. A person standing below sees only a soft curtain, but in reality, millions of tiny collisions are creating the aurora's rhythm, movement, and graceful flow. Standing beneath the aurora, the human eye slowly adjusts to the darkness. The delicate details of color begin to appear. Thin streaks of blue, faint pink folds of light, or dim purple edges threading through the green. This feeling is different from the vivid image captured by a camera. A camera gathers photons over several seconds, making the colors more striking and clear, but it cannot fully carry the soft rhythm that the eye senses. This difference makes the aurora both a physical phenomenon and a sensory experience, a meeting of human sight, light, and time. Nitrogen, though often less noticed, plays an important role. It creates purple and blue shades that curve along the green band, adding secondary layers that help the eye sense softness and motion. As charged particles follow magnetic field lines toward the polar regions, nitrogen responds in its own way, and the light it releases differs in altitude, color, and intensity. The combination of oxygen and nitrogen creates overlapping layers of color and moving folds of light, making the aurora seem alive, as if it is breathing and inviting the observer to move with its rhythm. Every aurora night is unique. The sun sends charged particles with different energies. Earth's magnetic field bends them along its own paths, and the upper atmosphere responds with colors and motion. One night may show only green, another may add red, purple, and blue, forming a layered band of light. Every moment is different, making the aurora a living experience that can never repeat itself exactly, and making the sky feel closer, softer, and more dreamlike than ever. Looking at the aurora high above, the observer sees not only color, but the connection between Earth and the sun, between the magnetic field and the atmosphere, between invisible particles and photons of light. Each layer of color, each fold of brightness, is part of the continuous meeting between a star and a planet, and the human eye only needs to follow the rhythm slowly in order to feel that graceful movement fully. This is the moment when nature both reveals itself and keeps its secrets, making the aurora a soft yet deeply informative story, enough for someone standing in the cold night to feel immersed in the sky and experience a northern night they will never forget. That feeling of softness, motion, and layered color is not only a scene to admire. It is a delicate combination of physics, light, atmosphere, and human perception, making each moment of the aurora feel both close and wondrous, both scientific and dreamlike, both gentle and alive. And it is this experience, with its slow movements and interwoven layers of color, that has made the aurora one of nature's most captivating phenomena, leaving a deep impression in the mind of anyone who has ever had the chance to witness it. An auroral band is never only a still strip of light in the sky. Once the human eye has adjusted to the darkness, once the greens, purples, blues, and reds begin to separate from the night, the observer often realizes that this light has a rhythm of its own. Sometimes it is only a faint arc lying low, like a very soft border between sky and land. Sometimes it rises, grows brighter, separates into thin folds, and slowly hangs downward, as if the sky is opening a layer of motion that daylight never reveals. A camera may preserve the colors more clearly than the human eye, but the eyes standing beneath the real night can sense something a single frame can hardly hold completely. The aurora does not only have color, it has rhythm. That rhythm does not come from wind on the ground. The pine forests below may be still. Snow may rest quietly on rooftops. The northern sea may only ripple in the darkness, and yet, high above, the light continues to change shape, as if another current of motion is passing through the sky. The green band fades at one end and brightens at the other. A purple edge appears and then softly dissolves into the background sky. A higher red layer, if strong enough, may rest like a very distant breath of light above the moving green curtain. These changes give the viewer the feeling that the sky is not completely still, even when everything around them is almost silent. In the earlier parts of this journey, we move through each layer of the phenomenon. The sun does not only send light, but also releases charged particles. The solar wind travels through the space between planets. Earth's magnetic field bends the path of those particles toward the polar regions. The upper atmosphere, with oxygen and nitrogen, receives energy and returns it as light. But even when all of those pieces come together, the aurora is still not a closed formula. It changes from night to night, from hour to hour, and sometimes from minute to minute, The reason is that the energy source behind it is not perfectly steady either. The sun is not a quiet lamp shining with perfect stillness. It is an active star, and that activity is sometimes gentle, sometimes stronger. The stream of particles leaving it does not always have the same speed, the same density, or the same accompanying magnetic direction. There are days when the sun's influence on Earth is relatively calm, making the auroral region weaker, thinner, sometimes visible only to a camera. Then there are times when the particle flow becomes stronger, carrying more energy and disturbing the magnetic region around Earth more clearly. When that happens, the polar sky can answer with brighter, wider, more vivid bands of light. If weather on the ground is the way the air around us changes, then we can imagine that around Earth there is another kind of weather, far higher, far thinner, and almost never touching daily life through familiar sensations. It does not soak a coat like rain. It does not shake a window like strong wind. It does not pull dark clouds across a city. It happens through charged particles, through magnetic fields, through disturbances from the sun spreading into space and then meeting the planet's invisible protective region. The aurora is the rare part of that weather that becomes visible to human eyes. On some nights, the polar sky is like a very calm lake. The stream of particles from the sun is still there, the magnetic field is still working, and the atmosphere is still waiting at great altitude. But the light appears only faintly or not clearly enough for a person below to recognize. A weak green arc may lie low near the horizon, almost blending into the darkness. An impatient observer might think that nothing is happening that night. And yet, above them, the system is still active. It is only whispering too softly for human eyes to hear it as color. Then, on another night, that same region of sky suddenly seems to awaken. The first band of light no longer stays low. It rises, spreads, then separates into folds of brightness running across the sky. The green becomes thicker. Purple or blue edges become easier to recognize. If the incoming energy is strong, red layers may appear high above, giving the feeling that the sky does not hold just one curtain, but many stacked layers of light. The person standing below may not know exactly what has changed in the solar wind or magnetic field, but their body senses that this night is different. The sky is responding more strongly. The aurora, then, is like a soft sign of large movements. It does not explain everything in words, but it leaves clues. When the glowing region expands toward lower latitudes than usual, that often suggests that Earth is receiving a stronger influence from the Sunday. When the bands of light change quickly, when the colors become clearer, when the glowing curtain spreads more widely across the sky, we are seeing the final result of a chain of interactions that began in space. The ground may still be quiet, but the outer edge of the planet is very busy. This makes the aurora different from many beautiful sights in the sky. A beautiful moon may make us think of light and shadow. A beautiful field of stars may give us a feeling of distance. The aurora is both beautiful and current in a natural sense. It tells us that something is happening right then between the sun and Earth. Not in a frightening or noisy way, but in the sense that our planet is constantly living within an environment larger than the lower atmosphere. On the ground, there is rain, wind, snow, and mist. At the outer edge of Earth, there are invisible disturbances that sometimes appear as green, red, and purple light in the sky. Modern science helps human beings do more than simply look up and wait in uncertainty. Satellites observing the sun can see active regions, eruptions of material leaving the corona, and changes that may affect the space around Earth. Other instruments measure the solar wind as it approaches the planet, recording its speed, density, and the direction of the magnetic field it carries. On the ground, magnetic observatories monitor how Earth responds. Each piece of data is like a small advance message before the polar sky may begin to glow. But forecasting the aurora is not like predicting when a lamp will be turned on. People may know that conditions are becoming more favorable, may see that the sun has sent a stronger flow of particles, may predict that the auroral region could expand, but the real sky still keeps part of itself unpredictable. Clouds may arrive at the wrong moment. City lights may wash out a weak band of light. Human eyes may not yet be adjusted to the dark. Or the aurora may appear, but more gently than people hoped. That distance between data and experience keeps the aurora from becoming too easy to grasp. It has patterns, but it does not lose its aliveness. On nights of stronger activity, the aurora can move far beyond its familiar polar regions. Places that rarely see it may sometimes catch a faint red glow near the horizon, a pale green streak to the north, or a strange light that makes people open their cameras just to make sure they are not mistaken. Moments like this bring the phenomenon out of the imagination of distant icy lands. The aurora no longer belongs only to Scandinavia, Alaska, Canada, or Antarctica. It reminds us that the whole Earth is connected to the sun. Only in different places that connection appears with different degrees of visibility. Still, it is important to remain calm when speaking about strong solar activity. Space weather can affect satellites, radio communication, navigation systems, and in some stronger cases, even power systems on the ground. But the aurora should not be described as a sign of the end of the world or something meant to frighten us. In the spirit of this journey, it is better seen as the most beautiful visible part of a system that human beings are learning to understand and monitor. A band of light in the sky can be both a sight that makes people fall silent and a natural piece of data showing how the outer edge of Earth is responding. We might think of a very distant lighthouse, not because it warns of danger, but because it reveals that a shoreline exists in the darkness. The aurora is similar. It does not show us the entire space environment around Earth, but it reveals that this place is not empty. There are particle flows, there are magnetic fields, there is an atmosphere, there are changes traveling from the sun to the planet. When the sky lights up, we do not see the whole system. We see only one colored outline of it. But sometimes, even a single outline is enough to make us realize that a vast structure lies behind it. Here, the closeness of the aurora lies in the way it turns the invisible into something we can feel. The speed of the solar wind is a number. The direction of the interplanetary magnetic field is a measurement. The vibration of the magnetosphere is a line recorded by an instrument. But when all of those things help open a glowing band across the sky, data suddenly becomes experience. The observer does not need to understand every index to feel that something is happening. They only need to look up, see the sky moving, and realize that the night is not absolute stillness. It is stillness with motion inside it. A strong aurora night can also change how a person feels about their own size. On the ground, a human being is very small. A coat, a pair of gloves, a breath turning white in cold air. Above, light is being born at great altitude, from energy that has crossed the space between the sun and Earth. But instead of making people feel abandoned, the aurora often brings a sense of being placed more correctly. Small, but able to see. Unable to control the sky, but able to learn how to read it. Not the creator of that light, but slowly able to understand the path that brought it to their eyes. Scientists read the aurora with instruments, while observers read it through presence. A satellite can see the auroral region from above as a glowing oval around the magnetic pole. A measuring device can record changes in the magnetic field. A forecast map can show which regions may have a chance of seeing the light, but a person standing beneath the sky reads it differently. Whether the glowing band is high or low, whether the color is clear, whether it moves slowly or quickly, whether the night is dark enough, whether the body has enough patience to wait. These two ways of reading do not cancel each other out. One gives us understanding, the other gives us memory. There are also nights when the data promises a great deal, but the sky does not open as expected. Clouds hide the glowing region. The aurora is weaker than predicted. City lights wash out the color. The person waiting may feel disappointed, but even that disappointment belongs to nature, because the aurora is not a scheduled product. It is the result of many layers of conditions coming together. The sun, the solar wind, Earth's magnetic field, the atmosphere, darkness, weather on the ground, and the sensitivity of the human eye. Only when those layers are favorable enough does the sky clearly show us what is happening above. On nights when everything comes together, the feeling is very different. The light does not simply appear, it seems to have a life of its own. A green arc opens, and folds of light run along it. A dim region suddenly brightens, as if awakened. Layers of color appear in turn and then settle back down. No sound comes from the sky, but the person standing below can still feel a rhythm. Not the rhythm of music, but the rhythm of energy entering the atmosphere, of the magnetic field bending pathways, of oxygen and nitrogen answering with light. That is when space weather, a concept that may seem distant, becomes a very close experience. When the glowing band fades, the system behind it does not disappear. The sun continues to be active, the solar wind continues to spread outward. Earth's magnetic field continues to receive, bend, and respond. The upper atmosphere still rests quietly at the edge of the planet, ready to glow again if energy arrives in the right way. The aurora may come and go in human sight, but the connections that create it never truly stop. They only return to an invisible state, waiting for another night, another set of conditions, another moment when the sky is dark enough for faint light to return. Seen this way, the aurora is not only a phenomenon of the polar regions, it is a reminder that Earth has more layers of life than we usually feel. Down low, there is wind, rain, snow, mist, and changes the body knows very well. Higher up, there is a region that interacts with the sun through particles and magnetic fields. Farther out still, the entire solar system moves in its own rhythm. A band of light in the sky is only a very small part of that picture, but it is enough to connect everyday life with distant space without making that connection feel tense or frightening. Perhaps that is why the aurora belongs so naturally to a slow night. It is not loud, even if its origins can be powerful. It does not need to be fully explained all at once, even though many layers of science lie behind it. It allows the listener to move from feeling to understanding, from color to cause, from one specific sky to the larger environment surrounding the planet. And once we know that the aurora is a sign of the spaceborne rhythms around Earth, the next step in the journey becomes natural. How human beings have learned to follow those rhythms, with the eyes, with cameras, with satellites, and with instruments that can read invisible signs before the polar night has time to glow. As the eyes grow used to the dark, the aurora begins to reveal itself more fully, and the observer realizes that the sky does not hold only a dreamy layer of green light. Soft folds of brightness curve, hang downward, or lift upward, changing constantly like a breath. Faint purple edges thread their way through the green, with touches of blue and pale pink, forming a symphony of light in which every moment is different. This shifting does not come from anything moving on the ground, not wind, not snow, not cloud. It comes directly from charged particles rushing into the upper atmosphere, colliding with oxygen and nitrogen, and returning energy in the form of gentle photons. The motion of the folds is uneven. At times they widen slowly. At other times they stretch quickly and divide into thinner layers. Each fold reflects a different interaction between particles from the sun and the gases high above. When those particles meet oxygen, green light appears. When they collide with nitrogen, faint purple, blue, and pink tones begin to emerge. From the ground, the human eye sees a graceful flow, but above, in the upper atmosphere, each collision is a tiny moment, its own rhythm, something no person can fully grasp, one piece at a time. Sometimes the folds separate, and then come together again, giving the feeling that the aurora is breathing. A high red layer appears above, faint but still visible to a careful eye. A soft blue edge runs along the green, making the band of light seem even gentler. The colors do not simply appear, they move, bend, and change their rhythm. This is different from what a camera records. The image in the camera is fixed, while the real light outside is always changing. The eyes and the body both begin to move with that rhythm, sensing the sky as something living, though still very soft and calm. As the night goes on, the folds of light begin to interact with one another in more delicate ways. A small fold of brightness may widen and curve around another green band. A thin purple edge may blend into a high red layer. These changes happen slowly enough that the person standing beneath the sky may feel as if they are watching a curtain drift in the air. Yet in reality, millions of tiny collisions are producing photon after photon, color after color, together forming the aurora the human eye perceives. Each moment is a delicate combination of energy from the sun, the guiding shape of Earth's magnetic field, and the response of the upper atmosphere. Watching the aurora does not feel like looking at a still painting. It feels more like listening to a piece of music being played slowly, where each note is a small but continuous event, and the person beneath the sky is the audience, moving with melodies so soft they are both seen and felt. A careful observer may notice the colors revealing themselves in a gentle sequence. Green first, then purple and blue along the edges, and sometimes a faint red layer higher above. Each color, each fold of light, tells its own story, yet all of them come together into something soft and alive. The graceful movement of the aurora also reflects changes in the solar wind and in Earth's magnetic field. When the sun sends a stronger stream of particles, the aurora expands, the glowing band rises higher, and the folds curve more dramatically. When the magnetic field changes, particles are guided into the atmosphere along different paths, creating subtle shifts that the eye can still notice. The aurora's soft rhythm is a visible sign of the meeting between Earth and the sun, where layers of energy cross, collide, and return light. Sometimes, one part of the aurora fades to make way for a new fold of brightness. Those movements can make the observer feel as if they are seeing the timeline of energy itself, particles from the sun arriving in the upper atmosphere, colliding with oxygen and nitrogen, creating photons, and spreading outward toward human eyes. Each moment may differ from the one before, making the sky constantly changing, never repeated, and always keeping the viewer curious. The experience feels close, yet still full of mystery, drawing the eyes, the mind, and the body into the rhythm of nature. Over the course of a long night of watching, the aurora becomes a many-layered story. Green, purple, blue, pink, high red, all of them appear, disappear, bend, and drift across the sky. The person standing below begins to notice that it is not only the colors that change, but the glowing band itself that moves, stretches, separates into layers, or comes together again. That rhythm never repeats itself exactly, which makes every night a separate experience. In that moment, human beings feel their connection to nature, small beneath the sky, yet still able to witness the subtle effects of the sun, Earth's magnetic field, and the high atmosphere above. The aurora, then, is both a physical phenomenon and a sensory experience. The direct observer moves in rhythm with the soft band of light, feeling each collision, each color, each movement through what the eyes can gather. Cameras, satellites, and observation stations preserve the detail, color, and structure. The difference between seeing with the eye and seeing with instruments does not lessen the beauty. On the contrary, it adds depth, making the aurora feel at once intimate and wondrous, scientific and dreamlike. And when the night begins to quiet again, when the glowing band softens and each layer of color slowly fades, the observer still carries the feeling of the sky's breathing. The aurora has not disappeared forever. It is only waiting for another night, another set of conditions, to open again into new colors and continue its unfinished story of the connection between the sun, Earth, and the polar sky. Forecast maps, long exposure photographs, and satellites quietly looking down on Earth's two poles have helped human beings understand that the aurora is not an isolated spectacle in the northern night. That band of light can be seen with the eyes, recorded by cameras, measured by instruments, and connected to the solar wind and the vibrations of the magnetic field. From a thin green streak above a snowy forest, it gradually becomes a readable sign. The sky is recording the meeting between our planet and the space environment around it. Once a sign can be read in this way, it no longer stops at Earth. Because Earth is not the only world living under the influence of the Sunday. Out there are planets larger, farther away, colder, with different atmospheres, different magnetic fields, different moons, and their own streams of particles moving around them. Polar light, then, is not only the story of snowy nights of Scandinavia, Alaska, Canada, Iceland, or Antarctica. It is one way planets reveal their invisible parts. On Earth, the aurora comes to human beings with a fairly gentle beauty. It often begins as a faint green arc, then opens into soft folds of light, sometimes with purple, blue, or pink edges, or a very high layer of red. Below it, the scene may be snow, a dark forest, a cold sea, an empty road, or a group of people standing silently in thick coats. The sky feels close enough for the eye to sense that the light belongs to the night we are standing in, while the mechanism behind it is distant enough to carry the mind through the sun, the magnetic field, and the high atmosphere. Leaving Earth, that same idea begins to change its shape. Jupiter does not have a polar sky in the way human beings are used to imagining it. There is no snowy forest below, no solid ground where a person can stand still and look up. It is a giant gas planet, rotating very quickly, covered in broad cloud bands, enormous storms, and a magnetic environment far stronger than Earth's. There, the aurora no longer resembles a gentle green curtain in a quiet night. It belongs to a much larger and more powerful system, where the magnetic field wraps around the space near the planet and traps charged particles across a vast region. What makes Jupiter special is not only its size. One of its moons, Io, constantly releases volcanic material into space. That material does not drift away silently and disappear. It is swept into Jupiter's magnetic environment, becoming part of the energetic particle flow around the planet. When these particles plunge into the upper atmosphere near Jupiter's two poles, auroral light appears, far more powerful and complex than the gentle image we are used to seeing on Earth. On Jupiter, the aurora is like the trace of an entire planetary machine in motion. The sun still plays a role, but it is not the only source that determines everything. Jupiter's enormous magnetic field, the planet's rapid rotation, material from Io, and particles accelerated in the space around it all help create the glowing regions at the poles. That light is often observed in ultraviolet light, X-rays, and forms of radiation the human eye cannot directly see. To see Jupiter's aurora, human beings must borrow the eyes of telescopes and spacecraft. Saturn carries that feeling in another direction. This planet is often remembered for the almost silent beauty of its rings, thin bands of light surrounding a cold gas giant far from the Sunday. But above Saturn's two poles, there are also glowing regions. There, the solar wind meets the planet's magnetic field, particles are guided into the upper atmosphere, and auroras form in kinds of light the human eye does not naturally recognize. Ultraviolet and infrared light become the keys to seeing a beauty that lies beyond the limits of ordinary vision. There are lights in the universe that were not born to please human eyes. They are still real, still carrying information, still telling stories about energy, atmosphere, and magnetic fields. But they need instruments in order to be translated into images. Saturn's aurora is therefore no less beautiful, simply because we cannot stand beneath it and see it with the naked eye. It is beautiful in a different way, quieter, farther away, more dependent on science, like a melody sounding at a frequency the human ear cannot hear until a special instrument translates it into a range we can sense. Mars tells a smaller and more somber story. The red planet no longer has a strong global magnetic field surrounding it like Earth does. Its atmosphere is also much thinner. On the surface are dusty plains, giant volcanoes, deep valleys, and a cold red color stretching toward the horizon. But within the crust of Mars, there are still local magnetic regions, like fragments of memory from a distant time when the planet may once have had a broader magnetic field. Auroras on Mars do not need to resemble Earth's auroras in order to matter. They may be weaker, more scattered, and appear in different ways, connected to the planet's remaining magnetic regions and thin atmosphere. That difference is precisely what makes them worth noticing. A weak glow on Mars does not only speak of particles from the Sun entering the atmosphere. It also suggests the lost history of the planet, the question of why Mars is no longer protected by a global magnetic dome like Earth, and how its fragile atmosphere is now exposed to space. On more distant planets, the story becomes even stranger. Uranus has a magnetic field that is tilted and offset in a way that does not fit a simple image of a planet with two neatly placed poles. Neptune lies very far away, receiving much less sunlight, yet it still has its own magnetic environment and atmosphere. Auroras on those worlds are not smaller copies of Earth's auroras. They are each planet's own expression, shaped by its magnetic structure, its layers of gas, and its relationship with particle flows in space. The farther we go, the less the aurora looks like a single image. It is not always green, not always soft, not always within the range the human eye can see, not always beginning from the same source of particles. On Earth, oxygen and nitrogen create the familiar colors. On Jupiter and Saturn, the atmospheres are made mostly of hydrogen and helium, the magnetic fields are much stronger, and the particle environments are more complex. On Mars, the thin atmosphere and local magnetic fields make polar light carry an entirely different story. The same name is used, but each planet speaks with its own material. These differences make auroras a tool for understanding worlds. By looking at polar light, scientists can learn about a planet's magnetic field, atmospheric composition, energetic particle flows, and the way the solar wind touches different places throughout the solar system. A glowing region on Jupiter tells of the strength of its magnetic field and the influence of Io. An aurora on Saturn shows how that distant planet responds to the sunday. A signal on Mars suggests a thin atmosphere and fragments of magnetic field left behind in the rocky crust. Light, here, is not only something to admire, it is the trace of structure. Human beings cannot step onto each planet and wait for polar light the way we stand beneath Earth's sky. No one can put on a warm coat and walk under Jupiter's aurora. No one can set up a tripod beneath Saturn's rings to photograph an infrared band of light. Those worlds require spacecraft, telescopes, spectrometers, ultraviolet sensors, infrared cameras, and vast amounts of data translated into images. Each instrument is like an extension of the senses, carrying human curiosity to places the body can never reach. Thanks to those extended eyes, the solar system feels less silent. The planets are no longer just distant spheres, each with a color and a number marking its distance in a book. They become worlds that are responding, being touched by the sun and leaving signals at their outer edges. Jupiter glows within a vast magnetic system. Saturn sends out its signs above layers of cold gas. Mars reveals thin lights beneath a sky that has lost much of its old protection. The more distant planets still hold many secrets, waiting for better instruments, longer observations, and more patient questions. After passing through those worlds, Earth's aurora feels more intimate. It is not the strongest aurora, not the widest, not the strangest, but it is the aurora that can be seen from a living ground. Oxygen creates green high above, while oxygen lower down enters every breath. Nitrogen adds purple and blue along the edges of the glowing curtain, while nitrogen also quietly surrounds human beings in most of the air they breathe. The sun sends particles from a great distance, Yet the final light enters the eyes of someone standing beneath a sky with snow, wind, breath, and memory. It is this closeness that makes Earth special. Not because the universe revolves around us, but because here, a planetary phenomenon can become a direct experience. Distant auroras must be translated through data, through false color, through images from telescopes. Earth's aurora can also be measured by every modern tool, but it has another path as well, from the upper atmosphere down into human eyes. A band of light may begin with a charged particle, pass through the magnetic field, touch oxygen, and end as a very quiet feeling in the mind of the observer. Once we know that other planets also have auroras, the glowing band in Earth's sky does not become smaller, it grows larger. A green streak over the polar regions suddenly carries within it a kinship with the powerful violet glows of Jupiter, the infrared lights of Saturn, and the faint signals of Mars. The same sun touches many worlds. Each world answers with its own material, its own magnetic field, its own atmosphere, and its own history, which has shaped what it is now. Earth answers with a light human beings can see. In that wide family, the aurora is like a shared language spoken in many different voices. No voice is exactly like another. Jupiter speaks with the power of a giant planet. Saturn speaks in signals beyond the range of human sight. Mars speaks through the fragility of a world that has changed. Earth speaks through the green of oxygen, the purple-blue tones of nitrogen, and through the very rare gift that someone can stand beneath it and listen with their eyes. A polar night, then, is no longer just a small point on a map. It becomes an entrance into a much larger picture, where planets are all living inside the influence of the Sunday. An observer may stand very still on the ground, but the imagination travels much farther. To Jupiter, with a magnetic field as vast as an invisible kingdom. To Saturn, with its silent rings. To Mars, with its thin sky and magnetic memories in stone. And after that journey, the eyes return to the glowing band in front of them, softer, closer, and deeper. Earth's aurora is no longer only a question of why the polar sky lights up. It becomes a reminder that a planet can respond to space with light, that beauty in the sky is also information about invisible structure, and that distant worlds are not completely silent. They have ways of revealing their nature, not through words, not through sound, but through glowing regions at their outer edges. And here, on Earth, that answer comes to human beings in a very gentle form. Not as an explosion from the Sunday, not as numbers on a satellite screen, not as a magnetic graph in a research room, only as a quiet ribbon of color against the night, born from the same laws that can make Jupiter, Saturn, or Mars glow in their own ways. A small light within human sight, yet one that is connected to the whole vast solar system. After moving through the distant auroras of Jupiter, Saturn, Mars, and other planets, the band of light in Earth's sky suddenly feels closer in a very strange way. It is not the strongest aurora in the solar system, nor the largest phenomenon that planets can create near their poles, but it is the band of light human beings can stand beneath, can wait for in the darkness, can see with their own eyes after those eyes have adjusted to the night. Among so many distant worlds that can only be observed through telescopes, spacecraft, and data, Earth's aurora still holds something of its own. It completes a long journey from the sun, through space, through the magnetic field, through the atmosphere, and finally ends in the gaze of a person looking up beneath a cold sky. That journey does not begin with green. It does not begin with the quiet of a polar night. At the starting point, there is no snow, no pine forest, no cold train window, and no white breath in the air. There is only the sun, a hot and constantly moving star, where matter exists as plasma, where magnetic fields twist and bend, where energy is continually created and sent outward. From far away, the sun may look like a familiar bright disk in the daytime sky, but in the story of the aurora, it is the source of a flow more hidden than sunlight, charged particles leaving the star and entering space. Those particles have no color for human eyes to see as they leave the sunday. They do not create a glowing streak through space like a meteor. They come with no sound, no visible shape, no shadow. They are simply part of the solar wind, an extremely thin but persistent stream of particles spreading through the solar system, like the material breath of the parent star. While life on Earth continues in familiar rhythms, a morning door opening, a sunlit road, an afternoon of low clouds, a northern night slowly darkening out there, in the wide space between planets, those particles are still traveling. The distance from the sun to Earth is too vast for ordinary intuition to hold. Human beings are used to distances between two cities, between a house and a shoreline, between the ground and the top of a mountain, but the space between a star and its planet belongs to a completely different scale. Light crosses that distance very quickly, while the particles of the solar wind move much more slowly, needing time to reach the region of space around Earth. During that time, Earth continues to turn, the oceans continue to move, clouds continue drifting over continents, and somewhere near the poles, no one may yet know that a few hours later, the sky will begin to change color. When that stream of particles comes near Earth, our planet does not receive it with a bare surface. Before anything can become light in the atmosphere, the charged particles have already met an invisible region surrounding the planet, Earth's magnetic field. No one standing on the ground can see the magnetic field the way they see clouds or the moon. It has no color of its own, does not appear as a glowing dome, and has no clear outline against the sky. But for charged particles, it is a very real structure, a region of influence that bends their paths, guides them, deflects them, or draws them toward areas near the poles. At this point, Earth begins to take part in the story. The sun sends out the particle stream, but the aurora is not something the sun simply imposes on the sky alone. Our planet has its own way of answering. The magnetic field does not allow every particle to plunge straight into the atmosphere everywhere. It gives the encounter more order, guiding part of the energy along curved paths toward the magnetic polar regions, where magnetic field lines reach deeper into the upper atmosphere. Because of this, the aurora does not spread evenly across the world's sky, but often appears as glowing regions around the two poles, as if Earth has two thin windows opening toward space. Beneath those invisible windows is the atmosphere. Near the ground, the atmosphere is breath, wind, the smell of rain, the sound of moving leaves, clouds, and fog. But the higher we go, the thinner the air becomes, and the farther it moves from every familiar feeling of life. The layer of air where the aurora is born is not a place where humans can stand, not a place where low clouds drift by or snow falls onto a coat. It is a very high region, where oxygen and nitrogen still belong to Earth, but are much closer to the edge of space than to the world human beings can touch. There, the particles guided downward by the magnetic field meet atoms and molecules of gas. A particle transfers energy to oxygen or nitrogen. That atom or molecule is excited for a very brief moment, and then, as it returns to a more stable state, it releases the extra energy as light. One event like this is far too small to create anything visible to human eyes. But the aurora is never the story of a single collision. It is countless collisions, spread across a large region of the upper atmosphere, quietly releasing countless photons until an entire band of light appears in the darkness. Color begins there. Oxygen often brings the familiar green, the color many people remember first when they think of the aurora. At other altitudes and under other conditions, oxygen can also create a faint red, higher and softer, sometimes like a very distant layer of light against the sky. Nitrogen contributes purple, blue, or pink edges, giving the auroral curtain more depth and softness. These colors are not decorations placed onto the sky. They are the atmosphere's way of answering energy, each color carrying a trace of the type of gas, the altitude, and the strength of the particles that have traveled the long path from the sun to Earth. From the place where the light is born, the photons begin to travel downward. They leave the upper atmosphere, pass through the layers of air below, cross the darkness, move through clear regions of sky or areas hidden by cloud, and finally touch human eyes. This is the last part of the journey, but it is also the part that makes the phenomenon feel most intimate. Before that moment, the aurora could still be data, interaction, physics, magnetic field, particles, and gas. When it enters human eyes, it becomes experience. A person may not see each particle, may not know each step of energy transfer, but they can still feel the band of light moving in the sky, like something deeply real happening within their own night. Human eyes do not record the aurora perfectly. In darkness, they may miss faint red, fail to clearly see purple edges, or turn a very dim green band into a pale gray. A camera may sometimes see more, because its sensor can gather light for several seconds and preserve photons that the eye only catches briefly. But that very imperfection makes the experience more alive. The person standing beneath the sky has to wait. They have to let their eyes adjust to the dark. They have to look a little longer before they can tell a streak of light from cloud. And then, when that band bends, fades, brightens again, or hangs down in soft folds, the recognition comes slowly, but more deeply. A person may remember the aurora through the photograph they took, but the truest memory often lives in the things a photograph cannot fully hold. The cold on the cheeks, the soft sound of snow underfoot, the silence between people standing together and looking up, the feeling of breath slowing when the sky suddenly brightens in a place that seemed empty. A camera preserves the colors, while the body preserves the time. So the aurora is not only light entering the eyes, it is also the feeling of one specific night, one specific place, one moment, when a person knows they are seeing something that has come from very far away. This is what makes the journey from the sun to the human eye so beautiful. It does not only pass through physical space, it also passes through layers of human understanding. At first, the aurora may seem only like something strange in the sky. Then the question opens: where does that light come from? One layer after another is slowly revealed. The sun does not only send light, the solar wind carries particles through space. Earth's magnetic field bends their path. The polar regions become places where energy can enter more easily. Oxygen and nitrogen begin to glow. Human eyes and cameras record the light in different ways, and other planets have auroras of their own. In the end, when we return to the first glowing band, it is no longer a simple streak of color. It has gained depth. That understanding does not make the aurora less poetic. It only gives its beauty a deeper foundation. A green band of light is not beautiful only because it is soft. It is beautiful because we know it is the result of a very long chain of transformation. A high red layer is not strange only because it is rare. It is strange because it speaks of oxygen at a different altitude, of particles with different energy, of the atmosphere glowing according to its own rhythm. A thin purple edge does not only add color to the scene, it reminds us that nitrogen, the invisible gas surrounding us every day, can also lend its voice to the sky when touched by energy from space. Earth also becomes more layered in this story. It is not only the ground beneath our feet, not only oceans, mountains, forests, and cities. It also has a magnetic field reaching outward, an atmosphere thinning into space, and polar regions where energy from the sun can enter and appear as color. Down below, oxygen enters every breath. Far above, oxygen glows green. Down below, nitrogen makes up most of the quiet air around us. Far above, nitrogen can create purple or blue edges along the auroral curtain. The same planet, the same familiar ingredients, but at another altitude, they tell a different story. From this point of view, the night sky is no longer a distant dome. It is the uppermost part of a planet living in relationship with the Sunday. Night is not the complete absence of light, but sometimes the condition that allows a weaker, more distant, more delicate kind of light to be seen. During the day, the sun fills the whole sky with direct light. At night, near the poles, the sun's influence can return in another form, not golden like sunlight, not warm like morning, but but green, red, purple, blue, thin and slow, like a reminder that this star still touches Earth through many different paths. A person standing beneath the aurora does not need to think of all this at once. Nature's script does not require the observer to understand every mechanism before being allowed to find it beautiful. Beauty comes first. A band of light appears, and people fall silent. Then knowledge arrives more slowly, like a second light behind the first. Knowing about the sun, the magnetic field, oxygen, and nitrogen does not replace that first silence. It deepens it, because the viewer understands that what is drifting across the sky is not a thin illusion, but the result of an entire system at work. Perhaps that is why the aurora can both soothe the mind and expand it. It does not push the listener into the tension of huge numbers or frightening scenes. It simply shows that between the powerful motions of the sun and the quiet of Earth's night, there can exist a kind of reconciliation made of light. Energy travels through space. The magnetic field bends it. The atmosphere turns it into color. Human eyes receive it as something gentle. A vast process, in the end, can arrive to us softly. In that sky, science and feeling do not need to be separated. Science says this is charged particles, magnetic fields, excited states of atoms, photons emitted by oxygen and nitrogen. Feeling says this is a very wide night, a very soft band of light, a moment that makes a person feel small but not lost. Both ways of seeing can exist together. One clarifies the path of the light. The other preserves the feeling of when that light arrives. And when the aurora fades, its journey in the human eye remains. The sky may return to darkness. The stars may become clearer again. Snow, forest, cold sea, or the window of a train may still rest in the night as before. But someone who has seen that band of light will find it difficult to look at the sky in exactly the same way again. They know that darkness is not always empty. They know that Earth does not only sit beneath the sun during the day, but lives within its influence all through the night. They know that a very gentle light in the sky can begin as a stream of particles, leaving a star millions of kilometers away. By the end of this journey, the aurora does not need to be treated as magic in order to keep its wonder. Its truth is already beautiful enough. A star sends particles outward. A planet with a magnetic field receives and bends that stream. A high layer of atmosphere takes in the energy. Familiar atoms release color. A human being stands beneath the night and sees all of it as a band of light. No step needs to be exaggerated. No layer needs to be made mystical. If we follow the path slowly enough, we can see that nature can be precise and still gentle, immense and still intimate, invisible, and yet sometimes able to appear as color. The aurora enters the human eye as the final point of a very long road, but in the feeling of the observer, it seems more like a beginning. From one band of light, we begin to ask about the Sunday. From one shade of green, we ask about oxygen. From one curved fold of brightness, we ask about the magnetic field. From one vivid photograph, we ask how human eyes see in the dark. From Earth's aurora, we ask about other planets. A phenomenon that may seem meant only to be admired suddenly opens many paths for curiosity, and that curiosity makes the sky feel deeper every time we look up. In the quiet night, when the last glow is only a faint streak against the sky, the journey from the sun to the human eye continues in thought. It no longer belongs only to particles and photons. It has become a way of seeing. A way of seeing Earth is not separate from space. A way of seeing the atmosphere not only as something to breathe, but also as a place where light can be born. A way of seeing the sun not only as daytime, but as the source of hidden colors in the polar night. And a way of seeing human beings as small, yet capable of noticing, remembering, and retelling the very distant signs of the universe in a voice that is slow, quiet, and calm. At the end of that long journey, the polar sky returns to the quiet it had at the beginning. The band of light is still there, but it no longer needs to be brilliant to hold the human eye. A thin layer of green drifts slowly through the night, sometimes opening into a long arc above the horizon, sometimes hanging down in a few very soft folds before fading back into the dark. Higher up, red may remain only as a faint breath of color, almost uncertain unless one looks long enough. The purple and blue edges, if they appear, also arrive very quietly, like a small detail the sky reveals only when the person below is patient enough. After all the layers we have passed through the sun, the solar wind, the magnetic field, the atmosphere, oxygen, nitrogen, cameras, satellites, and other planets, the aurora finally returns in its simplest form, light in the night. Not a graph, not a formula, not a list of technical terms, only a soft band of color above, too far away to touch, but close enough to make a person look up and fall silent. Perhaps the deepest beauty of the aurora lies there. It does not need to hide its scientific truth in order to remain wondrous. It does not need to be magic in a mystical sense. When we understand that this band of light begins with charged particles leaving the sun, crossing space, meeting Earth's magnetic field, being guided toward the polar regions, and touching oxygen and nitrogen in the upper atmosphere, the beauty does not disappear. Instead, it gains depth, because each fold of light in the sky is no longer a distant mystery beyond understanding, but the final part of a very long road. The sun has sent more than daylight. Earth has not simply stood still within that influence. The planet's magnetic field bends the invisible stream of particles, deflecting most of that motion away from where human beings live, while guiding part of the energy toward the two polar regions. The atmosphere, usually transparent and quiet, becomes the place where energy is changed into color. Oxygen, the same element that enters every breath down below, emits green light far above. Nitrogen, which makes up most of the air around us, contributes thin shades of purple, blue, and pink along the edges of the glowing curtain. The most familiar parts of Earth, in a different setting, suddenly appear in an entirely new way. On the ground, human beings may still stand very small in the cold night. A pair of boots leaves marks in the snow. A coat is pulled tight against the wind. A hand rests lightly against a window. A group of people says very little because everyone is looking up. These details belong to ordinary life, small and close, but above them, at an altitude where no human being can breathe, light is being born from a meeting between a planet and its star. The distance between those two worlds is immense, and yet, in the aurora, they are joined by something the human eye can recognize. The night sky often makes us think of distance. Stars lie at enormous distances. The Milky Way stretches through the dark like a faraway river of bright dust. Space can seem silent, wide, and cold, but the aurora brings a different feeling into the night. It shows that the universe is not only far away out there. Part of the universe is always touching the edge of Earth. The sun does not only illuminate the planet from a distance, it sends particles, sends energy, creates motions that our magnetic field and atmosphere must answer. And on certain nights, that answer becomes light. Not the strong light of noon, not golden light on the ocean, not the familiar city lights beneath our feet. The aurora is another kind of light, light born at the outer edge of the atmosphere, faint enough to need darkness, fragile enough that a camera sometimes sees it more clearly than the human eye, but real enough to enter the memory of anyone who has stood beneath it. It does not take over the whole world like daytime. It only opens a small part of the sky, then lets the observer enter it through attention. In that slowness, Earth appears not as a passive planet, but as a world with its own structure for answering space. It has a deep core that helps create a magnetic field. It has a magnetosphere extending outward, like a soft protective region. It has an atmosphere wrapped around its living surface. It has oxygen and nitrogen in its high layers, ready to glow when they receive energy in the right way. It has human beings below, learning to observe, measure, photograph, forecast, and retell what the sky has shown. The aurora, then, is not only a trace of the sun, it is also a trace of Earth, of the way this planet takes part in that meeting through its own invisible layers. Many phenomena in the universe can overwhelm us with power. A stellar explosion, a black hole, a distant galaxy, a giant storm on Jupiter. The aurora does not need to follow that path. It does not overwhelm through destruction or scale. It reaches the observer through transformation. An invisible stream of particles becomes a band of light. An atomic collision becomes green. An unseen magnetic field becomes a soft shape in the sky. A vast physical process becomes a deeply quiet experience. This is why the aurora belongs so naturally to the night. It does not force the mind to understand everything at once. It allows thought to move slowly. At first, there is only color. Then comes the question. Then each layer opens. The sun is not still. Space is not completely empty. Earth has a magnetic field. The upper atmosphere can glow. Human eyes and cameras see faint light in different ways. Other planets also answer the sun with their own forms of light. Each layer of understanding does not take away the quiet. It is more like adding another depth beneath the drifting band above. A person can watch the aurora without knowing every mechanism behind it. The beauty is still there, complete in its own way. But when we know more, when we understand that the green comes from oxygen very high above, that the light is not reflected but emitted from the atmosphere, that the magnetic field has quietly guided particles toward the polar regions, we can return to that same glowing band with a different feeling. Not less dreamlike, but with a stronger foundation for the dream. Not less amazed, but with a place for that amazement to rest. Science, when approached slowly enough, does not make the sky rigid. It gives the sky more depth. The aurora can fade at any moment. A green arc that was clear suddenly softens. A fold of light that was hanging downward dissolves into the background sky. A region of color that seemed about to expand becomes still again, returning the sky to the stars. That disappearance does not truly end the journey. The solar wind continues to spread outward from the star. Earth's magnetic field continues its quiet work. The upper atmosphere remains at the outer edge of the planet, waiting for the next time energy arrives under the right conditions. The aurora comes and goes in human sight, but the connections that create it continue, silent and persistent. Perhaps that coming and going is part of what makes it memorable. An artificial lamp can be turned on when we want it, and turned off when we no longer need it. The aurora is different. It does not belong to human will. We can forecast, wait, set up cameras, choose a place that is very dark and very cold, but the moment the sky opens, still keeps part of nature's freedom. It does not arrive to serve the observer. It happens because the sun, the magnetic field, and the atmosphere meet in the right way. Human beings are simply fortunate enough to be there and witness it. The wind still moves lightly across the snow. The sky above is no longer as bright as it was at the beginning, but a thin streak of light still drifts slowly, almost blending into the darkness. The person standing beneath it may not think of anything grand. It is simply that, for a few very quiet minutes, everything around them seems wider. The ground beneath their feet, the cold in the air, the distant stars, and the aurora slowly fading at the edge of the sky. That light does not hold us through shock. It holds us through a very soft feeling, as if the night has opened a small slit for Earth to reveal its most quiet work. A planet turning in darkness, a star still sending streams of particles across space, an unseen magnetic field, a very high layer of atmosphere, and finally color appearing in the human eye. All of it passes through itself without sound, leaving behind a band of light so thin that if a person blinked a little too long, they might think it had disappeared. In the polar regions, night can last a very long time. Snow makes every sound softer. Small towns sleep under yellow lights. The cold sea rests beneath the wind. Dark forests stand still as if listening. High above, if the conditions are still right, one final streak of light may drift by, so thin that it is almost only a breath of color against the sky. The viewer does not need to say anything. The silence at that moment is not empty. It contains the whole journey that has passed through it, from a burning star to a cold sky, from invisible particles to color, from the high atmosphere to the human eye. The aurora also changes the way we think about darkness. Night is not only what remains after the sun has set. Night is the place where weaker lights have a chance to appear. Starlight needs night. The Milky Way needs night. The aurora needs night as well, not because it belongs to darkness, but because darkness allows the human eye to notice its delicacy. During the day, the sun speaks in strong light. At night, near the poles, that same star can leave behind a whisper in green, red, purple, and blue, through the quiet work of Earth's magnetic field and atmosphere. Once we understand that, the sky no longer feels like a distant dome. It becomes the uppermost part of the planetary home we live inside. Down below are breath, rain, wind, snow, trees, oceans, and cities filled with light. Higher up, the atmosphere grows thinner. Farther out, the magnetic field opens into space. And beyond that is the sun, always active, always sending its influence outward. The aurora is the moment when those layers are connected by a visible line of light. We do not need to keep the aurora in the realm of mystery in order for it to be beautiful. Its truth is already gentle enough. A charged particle can leave the sunday. A planet can bend the path of that particle with its magnetic field. An oxygen atom can emit green light after receiving energy. A human being can stand beneath the sky and see the result of all those things. The more slowly we look, the more we realize that this chain of events is not dry at all. It is like nature's quiet diligence, where each layer does its part so that, in the end, the night can glow. If the final band of aurora fades away, its gentleness can still remain in memory, not only as a brilliant photograph, but as a new way of seeing Earth. This planet is not only a place where human beings walk across the ground, it is also a world interacting with space at every moment. It has not only an atmosphere to breathe, but an atmosphere that can glow. It has not only the daytime sun, but a sun that leaves traces in the night. It has not only what the naked eye sees immediately, but streams of particles, magnetic field lines, and atomic collisions waiting to be recognized through light. And when the story closes, what remains does not need to be a grand conclusion. A quiet image is enough. A polar sky slowly darkening, the stars becoming clearer, the snow on the ground still silent, and far above, the last band of light dissolving into the night as if it has finished giving its answer. The sun is still there, even though it is not visible in the sky. Earth is still turning, still surrounded by its magnetic field and atmosphere. Somewhere far above, invisible things continue to move. In that night, the aurora has done something very gentle. It has shown that Earth can answer the sun with light, not with sound, not with words, not with a violent spectacle, only with soft bands of color born at the edge of the atmosphere, slow enough for the observer to breathe with them, real enough for science to explain, and beautiful enough that even after we understand them, we still want to look up one